Hey everyone, welcome to this brand new series that is Love2D for beginners. If you've ever wanted to make your own 2D game, it might be simple Pong to something more advanced, then you're in the right place. In this episode, we'll cover what Love2D is, what kind of games you can create with it, how Lua fits into the picture, and finally, how to install Love and set up your first game project. So let's jump right in. So first things first, what even is Love2D? Love2D, spelled with Love with a umlaut, is a free open source 2D game engine that uses Lua programming language. It's lightweight, fast, and perfect for learning how to build games. So whether you want to create an arcade style shooter, platformers, puzzle games, or even simulators, Love2D has got you covered. And what makes it super beginner friendly is that you only need two things: Lua, which I assume you've already learned the basics of, and Love itself. Now, how Lua ties into Love? If you've been following our Lua course, you have already had a head start. Lua is a scripting language that Love uses to run your game. When you code a game in Love, you're writing regular Lua code, but inside that Lua code, there are a few special functions that Love understands. Functions like love.load, love.update, and love.draw. Think of it like this: Love gives you the game engine and drawing tools, and Lua instructs it what to do and when to do it. So that is how Lua ties to Love. Now, what will you be learning in this series? You will learn how to draw and animate things. You will learn how to handle user input like keyboard and mouse. You will learn how to play sounds, how to add basic game logic and collisions and scoring, and eventually we'll make our own mini game together from scratch. So every video will be short, focused, and packed with practical examples. Now with that, let's get to installing Love2D and setting up our project folder. And it is pretty simple. First, you have to head over to love2d.org, and this is their official website. You can check it out if you're curious about Love, about the community, about how it is open source, and down the games that Love has been used to make. And the most popular game, I think, as much as I know, is Bilatru. This title won the Game of the Year, and it was all made using Love2D. So you can make pretty cool games using Love2D, and let's get started with it. So to get downloaded with Love2D, you can get this Windows 64-bit installer or any package according to your operating system. I'm using Windows, so I'll just download the 64-bit installer. If I click on the download, it will start to download, and it'll be just done in a while. After that, you can just click on the executable file and execute it, and it'll open the Love 11.5 setup. I'm using this as the latest version, so I agree. And this is your default destination folder. I'll leave it as it is, and the next, and then install. As you can see, it has finished installing in a short while, so I'll click on finish, and you're done with installing Love. Now, if you've not installed Lua, you can check out our first episode of Lua, link in the description. I'll provide an executable files GitHub link in this video's description as well, so you can go check it out, and you can download and execute that to install Lua on your device. Now that is specifically for Windows. I have provided the link, and you can install Lua on Mac and Linux as well. So after that, you can get started with setting up your project. So in order to set up your first Lua project, let me just close this, and you can head over to anywhere on your PC. I'll create this on a desktop. You can create a folder and name it something like My First Love2D Setup. So setup. You can open this and then open this in command prompt and open this in VS Code. And after that, okay, I'll do this full screen. Yes, I trust the authors. Let me just reduce the size a bit. And after that, you can just create a Lua file. So it will be named main.lua. So main.lua. Right? Now inside this, you can start writing Love2D code. So let's first build a test project which will just output hello world onto our screen. So for that, we'll have to use a function of love. So after you have done installing Love2D on your device, this will execute just fine. So I'll type out function and then love dot draw, and then inside that function I will use love dot graphics dot print. And what we are going to print? We are going to print hello Love2D. And after that I'll provide the coordinates of how far that I want to print it. First, the x coordinate, I want to print it 100 to the right and then 100 downwards. So let me tell you, the default position for our outputs is 0 0. Instead of 100 100, it's 0 0, so it's at the top left corner of the screen. So if I type in 100 at love.graphics.print, it will print it 100 units from the left, so right here 100 units right and 100 units down. So it should appear somewhere here in the window that we're going to open. So after you're done, you can save your main.lua file. I've turned on autosave, so it has saved automatically. You can close this and close the folder all in itself. You can then locate to your local C drive and see in your program files, and then inside love. Now here is love, right? This is an executable file, so application. If you drag on your whole folder to this love, you can execute your Love2D code. So it says hello Love2D, and like I explained before, it's 100 units from the left and 100 units from the top. So your default starting position is here, and you can enter coordinates. And that is how basically love.graphics that we did. Let me just show you once again. So what I was saying, in love.graphics is the module that you use that handles everything related to drawing on the screen. It may be text, it may be shapes, images, and you name it. So when we call love.graphics.print, we're telling that graphics module to render our text at a specific position, like I explained before, inside the game window. And that is different from the regular print function, which just sends the text to the console for debugging. So after you're done with it, like I said, you can save your file and run it by dragging your folder. And on Mac OS or Linux, you can just run the command line, and you can use the terminal to execute love space dot inside your project folder, and it will execute. So congratulations, and just like that you have made your first Love2D app which says hello Love2D. And that was about it for this video. So far, we have learned what Love2D is, how it works with Lua, and we've even run our first mini program. So this is the first episode, so let's just keep it like that. You can use this graphics module to experiment, put this in different positions, output different text, you name it. Now in the next episode, we will dive deeper into love structure like love.load, love.update, and love.draw, and start interacting with your game window. If you have it already, make sure you'll download Love2D and Lua on your device and try writing that simple hello world program and variations of it. So if you found this video helpful or liked it, don't forget to like, subscribe, and hit that bell icon so you don't miss episode 2. Catch you in the next one. Bye bye. Hey guys, welcome back to the Love2D for Beginners series. In the last episode, we installed Love2D and ran our first Hello World program. Now if you missed that, you can go check it out. It will only take a few minutes. Link is in the description. And in this video, we're going to dig a little deeper and look at how a basic Love2D project is structured. And by the end, you'll understand how the game loop works using love.load, love.update, and love.draw, and how to display dynamic content on the screen. So let's get started. Now, about understanding the basic structure, Love2D revolves around a few special functions. You don't need a main function like in other languages. Love handles that part for you. And all you have to do is define functions like these in your main.lua file. They are love.load, which runs once at the start of the game. This function runs automatically at the start of the game. And love.update, and inside these parentheses dt, which stands for delta time, and this runs every frame, and it is used for logic like movement. So this will be explained and demonstrated in later episodes. And the last function is love.draw, which also runs every frame, and this is used to draw things on the screen. So Love calls all of these functions automatically as part of the game loop. You don't have to call them yourself. They are built into the engine. So let's explore these functions and start with our main.lua file from scratch. Now I'll exit out of this and then open our main.lua file inside VS Code, and this is empty, but here we will write all three core functions with some basic code. So first I'll write function and love.load, and inside our love.load function we'll initialize a message variable. So we'll say welcome to Love2D. After that we'll end the function, and then we'll create a function for love.update, inside it we'll use dt, which stands for delta time. Okay, inside it I meant delta time, and for now we'll keep this function empty, we'll not use this. And after that we'll use function love.draw, and inside love.draw we'll use the graphics module as discussed in episode 1, love.graphics.print. We'll print out the message and the coordinates of 100 and 100, and then end this code. Now here's what is happening inside this. In love.load we define a global variable called message, and its value is welcome to Love2D. And since we declare and assign a value to message inside love.load, which is automatically called once the game starts, it is like initializing a value at the start of the game. So suppose you wanted to start a game with 3 lives, right? You could write inside love.load lives equals 3. So this means that this text or our lives is all ready to be used later in love.draw or inside love.update without changing every frame. And inside love.draw we use the love.graphics.print to draw that message at the coordinates of 100 and 100. Now like I explained, it is 100 units from the left and 100 units from the top. So that is how these coordinates are working. Now let's save this. I have turned on autosave and then execute it using a batch file. Now I have created a run.bat batch file, and this is essentially to run our main.lua file without any hesitation. So at echo off we have just run our batch file by putting here the location of our love.exe file, and if I double click on our run.batch file, it'll run our Love2D for us. Now if you don't want to do this, you can just use our previous method, as you can head on to your local disk and navigate to your love file, and you can drag the whole folder onto love.exe. And now if we do that, it'll execute just the same, but since I want to reduce that tedious process, I'll use the batch file. Now as you can see, welcome to Love2D has been printed 100 units from the left and 100 units from the top. And if I were to print another statement, I would do it like this. So inside our VS Code I would just copy this line and I would print hello world 30 units further down. So if I save this and then drag this onto love, it'll print out hello world 30 units down from here. So that is how we are printing. Now about love.draw, our love.draw function is your canvas. So every frame, love clears the screen and runs this function, this whole function, again and again. So whatever you want to show needs to go inside love.draw. Okay, let me just extend this and let's make it a bit more interesting. What if we showed a score or the current time? So inside love.draw, instead of hello world, if we printed out score 0, so score 0, it would print that score onto that place. So I didn't want to move this, I wanted to execute this with love. So our score. So you can see that it is really easy to display more text. Later, you can try it out and replace a 0 with a score variable, and that is all for you to try. Let me know in the comments how it goes. Now, after love.draw, let's discuss about love.update. Now, this episode contains a lot of theory and minimal code, and the next episode will be moving objects. So that is where the love.update function will come in handy. Now, even though we're not using love.update yet, let's talk briefly about what that dt parameter, that is delta time parameter, means. So as I mentioned before, dt stands for delta time. It tells you how much time has passed since the last frame. And that's important for things like smooth movement and animations. Now, since this love.update runs in every frame, every device might have different frame rates. So some devices must have 60 FPS or 120 FPS. Now, we don't want our function to execute based on the frame rate alone. So what delta time enables us to do is it enables us to run the game smoothly and consistently, no matter how fast or slow the computer is. So even if it is 60 FPS or 120 FPS, we can just use delta time to make our movements smoother according to time rather than according to our computer's frame rate. So you can think of delta time like a stopwatch. It tells you exactly how much time has passed since the last step, so your game can adjust to movements and animations to match real time. So that is what the delta time function does. And with that, it is a wrap for our video. We learned about what Love2D's main function load, update, and draw do. You have displayed your own message using love.graphics.print, and I have explained what love.draw does, and you even got a sneak peek into delta time. In the next episode, we'll use love.update to move things across the screen, making our first interactive animation. So don't forget to leave a like if this video was helpful, and subscribe to the channel so you don't miss the next episode. And try editing the message text or adding more variables or lines to our love.graphics.print, and let me know how it goes in the comments. See you next time, and happy coding. Bye bye. Hey there guys, welcome back to the Love2D for Beginners series. In the last episode, you learned how love.load, love.update, and love.draw work, and how to display basic text on the screen, which we also covered in episode 1. And in this episode, we'll take things a bit further. We'll learn how to draw shapes like rectangles, circles, and lines. Not only that, how to set colors, and how to show dynamic text on the screen using variables. So let's get started right away. Now, Love2D makes it really easy to draw shapes, perfect for prototypes, heads-up displays, or even game elements like health bars. So let's start with some basic shapes, that is rectangle, line, and circle like I mentioned, with the function love.draw. So let me open up VS Code and my project folder side by side, and I'll start coding the function love.draw. So function love.draw, and inside love.draw, I will first of all create a rectangle, and the format for creating the shape rectangle with love.graphics will be, first of all, we'll have to write in a method. So method, and this will contain a fill or a line method. So, and after that, the coordinates of where we want the rectangle to be, and after that, the width and the height of the rectangle. So these are basically the things that we need when we make a rectangle. So first of all, let's say love.graphics. This is how we print on stuff to our screen inside love.draw. So love.graphics.rectangle will draw a rectangle. We will be using the fill method at first. Now what this will do is it will fill the rectangle inside with our selected color. Now we'll be selecting colors later on in the video. So first let's write 50-50 as the location coordinates. So 50 from the left and 50 from the top, as we discussed before. So 100, this will be our width, and let's say 50 will be, let's say 60 will be our height. Now with that, before we write on other shapes, let's test and see how our rectangle ended up drawing. So after drawing this, I suggest you guys run a batch file with your love.exe pathway. and you can use this to simply execute your main.lua file. So after I click on this, you can see that a filled rectangle is drawn 50 units from the left and 50 units from the top, and it has width 160. Now we can see that if we change the width to 70 and then run the file once again, it will change the width of the rectangle. It almost looks like a square. Okay, so that is how you draw a rectangle. Now what I was talking about, the method, was if we type in, now basically method can be two things, either line or fill. If we type in line, it will just draw the outer line of the rectangle. Now, and as you have already observed, when we use the method fill, it will fill the rectangle inside. So that is basically how the parameters work when drawing a rectangle. You have your method, you have your coordinates, and after that simply your height and width. Pretty simple, right? Now let's draw not only a rectangle but a circle and a line as well. Now as for our circle, when we draw a circle, the parameters it accepts are almost the same as the rectangle. So when we draw a circle, it will accept the method, which will be our line or fill, and after that it will be the coordinates of the center. So the x and y coordinate of the center of the circle, and after that, instead of width and height, it will be radius of the circle. So let's draw a circle, shall we? So love.graphics.circle, once again I typed crinkle, so circle, and after that we will use the fill method first, fill, and then we'll use a 280 coordinates for our center of the circle, and after that we'll keep the radius to 30 units. Now when we execute the patch file once again, or you can drag the folder onto your love.exe, we can see that a circle is drawn on the screen. And if I change the method to line, it will be the same, but it will not be filled inside. So that is how you draw a circle. Now as for our line, so line, the parameters will be first the x1 and y1 coordinate. This will be where the line starts drawing, and then the x2 and y2 coordinates. So this will be where the line stops drawing. So if I type out love.graphics.line, and inside that we'll do 350 and then 400 and let's say 100. Now if I do this, it basically means that our line starts drawing from the 300 units from the left and 50 units from the top. So it will start drawing from x1 and y1, and it will stop, its end point will be at x2 and y2. So 400 units from the left and 100 units from the top. So that is how drawing a line works. And these are how shapes work in Love2D. Now by default, Love draws everything in white, and if we want to add color, we can set the drawing color using something called love.graphics.setColor, and inside setColor, so I'll just show you directly. If I don't have to remove all of this, I can just add colors. Now if I want to add a color onto this rectangle, before drawing the rectangle with love.graphics.rectangle, I can set the color with love.graphics.color. I mean set color. So set color, here's the set color, and then we can use the RGB values. So 1, 0, 0. So when using RGB values while using set color, the maximum value will be 1 and the minimum value will be 0. So you'll be working with values from 0 to 1. So since I set the color of the rectangle to red, now essentially everything will be red: rectangle, circle and line, because I have used set color before drawing all of these. So if I execute this, see, all of these will be red. Now if I want to set a different color for our circle over here, we will have to use the set color method once again before drawing our circle. So before our love.graphics.circle line, I will type out, so let me just copy this, Control C and Control V. Now suppose I want to give this a green value, so I'll do 1. Now if I do this, our circle and line will both be green since since love.graphics.setColor have been used before our shapes have been drawn. So if I do this, see, green. Now if I want to add a blue color to our line, I'll just have to do the same. Before drawing our line, I'll have to put in a red, blue, green value. So this will be 1. This will turn out blue. So that is it. And if you want to reset your color to white, you can just fill out all of these 1, 1, 1. Now suppose I want to type some text, right? So I use love.graphics.print hello world. And I do that 500 units from the left and 50 units from the top. So without resetting the color, it will just print out hello world in blue. But if I want to reset the color, I can just use love.graphics.color, set color, and fill all of these values to 1. Now if I run this by doing that, see, it prints out white hello world. So that is how you use set color and reset the color using our 111 value. And a quick tip, you should always reset your color back to white after drawing, or else your text and future drawings will inherit the last color, like I demonstrated. So that is how set color works. Okay, now that we have explored drawing shapes and setting colors in Love2D, let's make our display interactive by using variables. This is great for showing scores, player names, health, timers, you name it. So first of all, I'll remove all of this and create a local variable called player name, and which will equal to Sam. And after that, I'll create another local variable called score, which will equal to 0 for now. Now inside our love.draw function, we'll first of all print out the player name. So love.graphics.print, we'll say player space, and then concatenate. This is the concatenation operator in Lua, if you didn't know. So we'll concatenate our player name. So player name, and we'll be printing out that at the coordinates of 50 and 200. Okay, I meant to type out a comma here, so 200. After that, we'll create another love.graphics.print. So we'll print the score now. So score, concatenate our score value, and then this will be at 50 and 230. Let's end this here. Now here we are using Lua's string concatenation operator to combine text with variable values. Now let's see how this turns out. So player Sam and score 0. So we have successfully used our variable values into our Love2D display. Now we can try changing the score value with our love.update to simulate it increasing over time. So as we have discussed love.update in our previous episode, I will demonstrate how it actually works. Now we'll still not be using the dt parameter here, but in further episodes where we make our objects move, we'll be using the dt parameter. So if we type out score.1 and end, let's see what will happen. So I'll give you guys a brief overview of what love.update does before I run our main.lua file. What Love2D does is it runs our love.update function over and over each frame. So with one frame, this function runs one time. So if there are 60 frames per second, this function will run, that is love.update will run 60 times per second. So our score value will be increased by 60 times per second. So if we run our main.lua file, you can see the score value increases. And if you pay attention, you can see that it increases by a fold of 60. So if we count 1, it reaches 60, and 2, in 2 seconds it reaches 120, and it just keeps increasing. So my monitor is basically 60 fps, and that is why this function is executing 60 times per second. Now that is how our love.update function works. And that was it for this video. Awesome work today. Let's recap what you learned. We learned how to draw shapes like rectangles, circles, and lines, how to set custom RGB colors on those shapes and text, and how to display dynamic text using Lua variables. So in the next episode, we'll be learning how to handle user input in Love2D. If you enjoyed this episode or found it helpful, hit that like button, subscribe to the channel, and comment what kind of game you're hoping to make. We'll catch you in the next one, and until then, bye bye. Hello everybody and welcome back to Love2D for Beginners. So far in this series we have drawn text and shapes on the screen, we have given them colors, and we have displayed dynamic content on the screen. But games aren't fun unless the player can interact with it. So today we are going to be discussing about handling user input. Now in this episode we'll explore the two important functions. They are love.keyPressed and love.keyboard.isDown. Love.keyPress triggers once when a key is pressed down, whereas love.keyboard.isDown checks if a key is currently being held down. So we'll be discussing first of all love.keyPress inside our VS Code. So we have opened this folder and we have to open the main.lua file. And inside main.lua we can start with using love.keyPressed to react to key taps. So first of all, I'll create a local variable called message, which will first be an empty string. After that, we'll create a function love.keyPressed, and inside this we'll enter the key. Let's say we want, okay, why? Now let's say we want to display something if the key is a space key. So if this key is space, then you can write message will be space bar was pressed, and after that we'll end the function. And let's write our function love.draw to draw that output onto our screen. So love.graphics dot print, what will we print? We'll print our message onto our coordinates, let's say 100 and 100, and we'll end the function. Now if we press any key, this function will activate once, and if the key is equal to space, then it will type out spacebar was pressed. So let's run our batch file. Once again, I have entered the location of our love.exe file onto this batch file with pause, and if I execute this and press space, we can see that spacebar was pressed is printed onto our screen. Now so let's say you don't want to detect just spacebar, you want to detect any key that was pressed. So if I do here, if I remove this if condition, oh, I didn't mean to do that, I meant to remove this and then this. Let's see, we want to detect any key that was pressed, so we'll concatenate key dot dot, this is the concatenation operator, was pressed. Now what will happen is if we run our batch file and press any key, so let me press J, so it will say J was pressed. It will detect any key that was pressed. So if I press L, L was pressed. This is L, by the way, small L. And so that is how love.keyPressed works. Now just like I did, you can try replacing the spacebar with any key that you press on the keyboard, and you can check for any key this way. You can use this to shoot a bullet, pause the game, or open a menu. And now that we have discussed about love.keyPressed, let's use the arrow keys to move a rectangle across the screen, and we'll do that with the help of love.keyboard.isDown. So first we'll create a position variable and update it using isDown inside love.update. So let me remove all of this. Okay, let me first define a position of our rectangle. So position of rectangle will equal to, first of all, our x coordinate will be equal to 100, and then our y coordinate will also equal to 100. Now after that we'll define a variable called speed, and it'll equal to 200. Now this will be in pixels per second. This will be the speed at which our rectangle moves. So we'll define a function love.update. Now do keep in mind that love.update runs every frame that our game runs. So love.keyboard.isDown. So let's say we press the right key, right? So right, if our right arrow key is pressed down, then we will increase the position of the X. So if our right key is pressed down, the rectangle has to move right? So the X position should be increased by a fold of our speed. But not just our speed, we will increase it by speed times delta time. Now I'll explain the concept of delta time and why we have to multiply our speed by our delta time. Now, but before we do that, we'll define an else if condition. Else if our love.keyboard is down is left, then we will decrease the value of our X coordinate by a fold of our speed, and not only speed, our delta time as well. So delta time, and this is the end for our if condition. And after that we'll define another if condition, and this time it will be for our up and down arrows. So if love.keyboard, okay, let me just copy this and just change the values. Control C, Control V, and after that, if it is down, then our Y coordinates should change. So Y will increase by a fold of speed into delta time, and if it is up, then Y will decrease by a fold of delta time. Now after our end, we'll end the function as well, so end. And as for moving our rectangle, that is drawing our rectangle, we will use draw, and then we'll draw love.graphics dot first of all we'll set our color to be a bit blue, so 0.2 and then 0.7, and let's say a whole value of 1, so 1. Now this will make our rectangle color blue because this is RGB, red, green, blue. And we'll type out love.graphics dot rectangle, and we'll use a filled rectangle, and then the X and Y coordinates, and let's say the rectangle is really a square, so we'll do 50 width and 50 height. And now let's end this function and test out our code. So end. Okay, let's run our batch file. Now you can see here is our rectangle, which is really a square. Now if I press the arrow keys, it will move left. Okay, for some reason when I press left, it is moving diagonally. Now why would that be? Oh, so this should be actually up. Okay, let's run our file once again. Sorry for that mistake. Now okay, left, right, down, up. Okay, this is fine. We are moving our square up and down. Now here's what is happening in our code. X and Y track the position of this rectangle, and when an arrow key is held, we add or subtract from that position value. So when we press our right key, we can see that we are adding some pixels per second position values to our already existing X value. So when we press right, it is adding this value onto our X value. Now why do we have to use delta time? Now delta time is basically the time it took to render the last frame. So if we open Xclarity Drawer right here, let me explain this. So if this and this is 2 frames, so this is first frame and this is the second frame, this value is delta time, and it is constant. It has a constant ratio for how much FPS your device is running at. So if your FPS is 30, the value of dt will equal to 1 by 30, so because it will be that many parts. And if your FPS is 60, it will be 1 by 60. Now what will happen if we don't use delta time? If we don't do speed times delta time, don't mind my handwriting, this is speed times delta time, it will differ speed according to our device. So let's see if I remove this delta time value, what will happen when I press right. Let me press run, and then if I press right even a bit, see how fast the square moves. Okay, I have to press left a bunch just to bring this back, but if I do just one click of the right button, it increases the value of x by that many folds. So it is because our love.update function runs every frame. Now if we do some calculation, if there are 60 frames in our computer and this function right here, okay, now if love.update runs 60 times per second, it will increase the value of x by a fold of 60. So we have already the value of speed is 200, and if we multiply it by 60, it will result in 12,000 pixels per second. So that is why the square was moving that fast when we press just one right key. See, now in order to bring that back, I have to keep pressing this left key for a while. And now in order to remove that tediousness, so let's execute this once again. Okay, now we have super speed on our square basically. So how this works is, if my device was running at let's say 30 fps, 30 into 200, it would just equal to 6,000 pixels per second. Now that is pretty fast, but we can see that because our specs or the FPS that our device or game is running at is different, it will induce different speeds onto different devices. Now we don't want that. This means the same code can make your rectangle fly like a rocket on a 144 Hz monitor, but crawl like a snail on a 30 Hz one. So the solution to that is delta time. Now as I said, the delta time differs according to the device. So if the device has 60 fps, it will have a delta time value of 1 by 60. Now if we multiply our speed times our frames times our delta time value, what will happen? If our speed is 200 and we multiply it by, let's say, 60 fps, so 60, and our delta time, which is 1 by 60, you can see that frames per second and delta time values cancel out, and we'll always have a constant speed value. So let's say our 30 Hz monitor will run at 200 speed, this 200 speed, but the value of delta time will be 1 by 30. So the speed of the rectangle will be the same in every device, and that is basically what this table is trying to signify. This table right here. If we use delta time with our speed value, no matter the FPS, the distance covered in 1 second will always be constant. So that is why we have to use delta time. And that was it for today. Today we learned how to respond to single key presses with love.key pressed, how to use love.keyboard.isDown to create smooth movement, and how to combine key input and delta time to move shapes across the screen. And in the next episode, we'll be loading our image sprite and draw it instead of a rectangle, so your character is about to come to life. If you found this video helpful, make sure you drop a like, subscribe to the channel, and let us know what kind of movement mechanic you want to build. And I do hope you don't just follow this tutorial, it encourages you to try stuff out on Love2D on your own. So until then, until the next episode, bye bye and happy coding. Hey everyone, welcome back to the Love2D for Beginners series. Up until now, our games have looked like a bunch of rectangles and circles. But games aren't just made of shapes. They are made of characters, coins, enemies, and backgrounds. So today, we'll learn how to bring our games to life using images. You'll discover how to load and draw image files, how to position them anywhere on the screen, and what a sprite is and why it is important in 2D games. And just a quick shout out, if you are learning Lua, you can check out our app on the Play Store, Lua for Games to Learn and Code. It is packed with interactive courses, fun coding challenges, and a built-in Lua compiler and step-by-step guides to build games like Brick Breaker. It is perfect for beginners who want to learn and practice Lua all in one place. So you can go check it out on the Play Store from Codin, Lua for Games, Learn and Code. Now let's get on with the video. Now, before coding, let's understand sprites. First of all, what is a sprite? A sprite is simply an image that is used in your game. It could represent anything. a player, an enemy, a coin, or even the background. Think of it like a sticker. Image file is the sticker, and your job is to place it on the game screen. Later, we'll also work with sprite sheets, which are big images that contain multiple smaller sprites for animations. But for now, a sprite is equal to one single image. Now, let's prepare your project to load a sprite. First, you have to download a small PNG image inside your main.lua folder. I have downloaded an image of an Among Us character, but after this, you can download any image and work with it. Now, after downloading your image, you have to place it in the same folder as your main.lua file, and here's what your project structure should look like. We have our main.lua file and our PNG that we want to use, and this batch file is simply to run our game, which I have also mentioned in previous episodes. So let's open our project folder and our main.lua file to start using our PNG image. So first of all, we'll create a variable for our sprite, and we'll call it local character. So this will be our variable that we want to use. Now inside function love.load, this is what we'll use to load our PNG image onto this character variable. We use love.graphics.newImage. So first of all, we'll write character equals, now we'll use love.graphics.load, new image, and then the name of the image. So I have written it as among.png, and this line basically loads your sprite onto our variable, and after that we'll end our function. So this is it for our love.load, and after that we will have to draw that character onto our screen. Now we do that by using function love.draw, and inside love.draw we'll use love.graphics.draw to display the sprite at a position of 100 and 100. So love.graphics.draw, since we are drawing something onto the screen, character, and then the position of 100 and 100. After we are done with that line, we'll write end. Now I have autosave turned on, so we can directly see by running this batch file what it results to. So you can see that this Among Us image is loaded onto our game window. Now we can visibly see that the image is way larger than it should be, or we would need for a character, and to fix this we can use the property that love.graphics.draw actually accepts. So love.graphics.draw actually accepts 6 main arguments. So they are first of all love.graphics.draw, first of all the actual image which we have stored in character, and then our position. So this is normal and as default, but after that it will also accept rotation and scale X and scale Y values. So scale Y, so it will accept these values, and we know that X and Y are to position our character onto our screen. So it is 100 pixels from our left edge and 100 pixels from our top. So rotation is how much we want to rotate the image. We'll cover this later since we don't really need this. And scale X and scale Y are how much to scale the image horizontally and vertically. So in order to scale our image, we would need to do so. First of all, let's leave it at this to draw the character at its original size. So we'll compare. After that, let's draw a smaller version of the character, and we'll do that by using our scale. Now love.graphics.draw will draw our character. Let's position our character further away, so 400 and then 100, and inside our rotation we'll keep it 0 for now, and for our scale we will have to scale it down to 50%, so we'll use 0.5 and 0.5 on the horizontal scale and 0.5 on the vertical scale. So let's execute our batch file and let's see the results. So you can see that our character has been scaled down, and that is how you control the size of your character in your game. Now if you want to make a bigger character, we could do it like this. If we want to double our size, we can multiply it by 2, both the x-axis and y-axis, and if we run it, it'll be way larger. So that is how you scale and manipulate your size of your characters in Love2D. But you have to be careful while using different x and y scales. I suggest you use the same x and y scale, since it will scale the character proportionally. But if we put it as 2 and 1, let's say, okay, let's comment this out and print this out at 100, we can see that our character will be a bit distorted. See, it's wide among us. Now, to keep your sprite looking normal, you should always use the same value for both scale x and scale y, unless you intentionally want some distortion. Now, that was about manipulating the size of your image or sprite in Love2D. But sometimes you might need to know how big your image is in the first place. For example, to center it on the screen or to create a hitbox for your character. So Love2D makes this easy with get width and get height. And we'll use this on our code. So let's remove all of this. Actually, we don't need to remove this all. So we'll create local character width and then character height. And inside love.tool, we will use this these properties or our variables to store the character width and character height. So we'll access the we'll access the width of our character by using something called get width, and then for our character height, we'll use character and then a colon and get height. Now we'll display, first of all, we'll draw this image as at a fixed position. We'll remove the scaling, and now what we will do is we will display the character information on the screen. So we'll use love.graphics.print. First of all, we'll print the let's say we'll say width, and then we'll concatenate the character width at 10 10. After that, love.graphics.print height will concatenate the character height at, let's say, 10 and 30. So these are the locations on the screen. Now let's see what our main.lua file outputs do. So we can see that our width is 440 and our height is 482. Now you can also use this information to center our sprite on our game window, which might come in handy later. And don't worry if this feels too complicated for now, you'll understand it better later. So our bonus, let's remove this. And let's first get our screen size. We'll have to get our screen size. Get screen size. And we can do that by using something called get dimensions. So we'll store our screen width in screen W, screen width, and screen height in screen H, and equals love.graphics dot get dimensions. So our screen width and height will be stored in screen W and screen H, and then we can finally draw the sprite centered on the screen. And we'll do that by using graphics, love.graphics dot draw. We'll draw our character, and for our position values, we'll balance it out with our screen width minus char width by 2. This will center our character horizontally, and for our vertical positioning, we'll use screen height minus our character height by 2. Now if we comment this line out, since we don't want this, and let's see what happens. So we can see that our character is centered. And this is incredibly useful when you want to start working with menus or UIs for which you want to center them on the screen. And that was it for today. Awesome job. Let's recap what you learned today. You learned what a sprite is and why we use it. We learned how to load an image using love.graphics.newImage, and we also learned how to draw it with love.graphics.draw. We learned how to get the dimensions of the image and also how to properly size and scale the image to your liking. Now in the next episode, we'll make your sprite move using the keyboard, just like a real game character. And it is pretty similar to the previous episode for keyboard inputs, handling user inputs, but we'll add some extra spice onto your character. Now, I hope you practice by loading any image you want onto your game file, positioning them anywhere you want, and scaling them to your liking. That is, you don't just follow this tutorial, but also experiment and try it out with your own game file. And don't forget to drop a like if you found the video helpful, subscribe to our channel for more such videos, and we'll see you guys in the next one. Bye bye. Hello everybody and welcome back to the Love2D for Beginners series. In the last two episodes, we learned how to move a simple rectangle on the screen using delta time and how to load and draw your image onto your game window. And in this episode, we are going to combine those foundational topics and take things up a notch. Instead of just moving shapes on the screen, we'll load an actual character sprite and move it smoothly across the screen by, of course, using delta time. And not just move the character on the screen, we are going to make the character face left or right according to the keyboard input, and not only that, we're going to limit the character onto our visible game window so that it doesn't go off bounds. So by the end of this episode, your game will start feeling much more alive. And without further ado, let's get started. Okay, I have opened my Love2D folder, and inside that I have opened my main.lua file inside VS Code. Now let's start by creating a basic player setup. Instead of just a rectangle, we'll load an actual image as our sprite, like we did in our previous episode. So okay, let me click here and then start with our local player, and inside this we'll be using a table. So I hope you know about tables. If you don't know what tables are, we do have an episode on Lua tables, which is a part of our Lua for Beginners series. So I hope you check that out. Link will be in the description. But besides that, after creating our player table, we'll create a speed variable and we'll give it the value of 200. And let's say it is meant to be pixels per second. And after that, we'll create a function called love.load, since we want to load our character sprite onto a variable. So we'll create an image key. So even if you don't know about tables, it is just a data structure inside Lua with key and value pairs. So if I type out player.image, this image is basically a key inside this table which will store some value. So if I type out player.image, it will create that key inside this player table. Now we'll use love.graphics.newImage to load our character sprite onto this player.image key, and inside that we will be using our Mario, that is I've named this Mary.png. So this is basically a PNG of our 8-bit Mario character. So this will be our PNG that we'll be using today. Now after that, we will create the X and Y position for our player. So we'll create an X key, and let's say our initial position will be 100, and that is 100 units from the left of the screen. And after that, our position value, Y position value, will be 100 as well. So it will be our position from our top. And after that, I'll create just another key, and this will be our boolean to describe if our player is facing right or not. Now we'll be using this variable or this boolean to flip our sprite further in the future. So for sprite flipping. After that, we're just about done with our love.load function, so we'll end our function, and then we will move on to moving our sprite using the arrow keys. So for that, we'll have to use the love.update function inside Love2D. So this is a function that will run in every frame of the game. So inside the parameters, we'll use dt, that is delta time. And inside love.load, we'll use love.keyboard.isDown. Since movement is continuous and we have to make the character move while we are holding down our key. So we'll use if love.keyboard.isDown. Now if our right key, that is our right arrow key, is down, then our player.x value should be increased. So player.x plus, it should be increased by our speed factor, and which will then be multiplied by our dt variable. So this stands for delta time, and I'll explain with a full presentation on why dt is so important in a while. So I'll create all of the functions and logics for our left, right, up and down movements, and then I'll explain about what dt means. So after that, I'll create player. Since if we press the right key, the player.facing right value will be true. And after that, I'll just copy this function, if condition, and paste it 3 more times, since we want one for left, one for up, and one for down. So if our player, if we, the users, press the left arrow key, the x position of our player, so suppose the player is right here. If we press left, it should go left. So the distance from our left edge, that is our x value, should decrease. So that is why we have to decrease our x value by speed times delta time. And since when we press our left arrow key, the player should face left, so dot facing right should be false. It should not face right. And after that, if our key is down, then our not player.x, our player.y value should actually increase. Since if we press down, the distance from the top of our screen should increase. If we press down, it should keep on increasing and our character should move down. So that is why we are using the increase or sum value. And facing right, let's say in this condition, is nothing. So when we press our keyboard down or up, it does not matter where our player is facing, so it does not determine that. So we'll cancel this in here as well, and we'll put this y value as minus for our up arrow key. So minus speed times dt, and this will be up. And after all this, we'll end our function, that is, we'll end our love.update function. Now this is how our love.update function will work. And let me just demonstrate the functioning code or the game, and then I'll move on to the explanation of delta time. And okay, for our character to be actually drawn on the screen, we have to use love.draw. So inside love.draw, we'll use love.graphics.draw. Since we are going to draw our player image, we'll access player, the table, and inside that we'll access the image key. So image, player.image, we'll have to draw the player at player.x position and player.y position. Now after that, we are done with our love.draw function. So let me end it and save it. I have autosave turned on and execute it with this batch file. And if you're new to our series, this is the batch file containing the location of our love.exe folder, love.exe executable file. And if we run this, it will execute our current game. So this is our sprite, our character, our Mario character that is loaded onto the screen. If I press right, it will move right. If I press left, it will move to the left. If I press up, up, and down, down. Now you might notice that this is not flipping. Mario is not facing left or right when I press left or right, and we'll fix that just a bit later. But before that, let me explain how delta time works and why it is so important to move characters on our screen. Okay, imagine this. You're running a car in your game and you want that car to move at 100 meters per second. Now, if a computer is running a game at 30 frames per second and another computer is running a game at 120 frames per second, if we just move the car 5 pixels per frame, the cars on the higher FPS computer or the game running on a higher FPS would zoom around like lightning, whereas on the computer where the game is running at a relatively lower FPS, let's say 30 FPS, the car would crawl much slower. So it would go this much slower. And that is where delta time comes in. Delta time aims to fix at this problem. Delta time tells us exactly how much real world time has passed between the last frame. So you can call it as a distance, or the time distance between two frames, and its value equals to 1 by the total number of frames. Now when we multiply the speed or add our speed inside our x value inside the love.update function, what will happen is, since love.update runs every frame, the speed value is added onto our x position value in every frame. So at a computer running a game at 120 fps, the speed value is added onto our x value a total of 120 times. So the x value will be increased by 24,000 times each second. Now this is still a lot, but this is not the point. The point is that in a device with a lower FPS, or let's say where a game is running at a lower FPS, the speed value will be added onto our x position value only 30 times. So our x position value will be increased relatively slower. Now we don't want the speed of game characters or any objects inside a game to depend upon the number of frames the game is running at. The speed of a car should be constant no matter the game is running at 120 fps or 30 fps. So delta time aims to fix this. Now if we multiply the speed value with delta time before adding on to our x value, what will happen is, even if the game is running at 120 fps, it will balance out the number of frames or the speed that is being added onto our x value. So 120 and 120 will cancel out, since the value of delta time, as we discussed just before, is 1 by the total number of frames. 120 and 120 will cancel out, and the distance or the position of x value will be just increased by a constant of 200. Now why delta time is really helpful is, even if the game was running at 30 fps, the value of delta time would be 1 by 30. So 30 and 30 would cancel out, and we would still end up with a constant speed of 200. Now we can see that when we multiply our speed by our delta time value, the speed of an object or the increase in x position of an object does not depend upon the number of frames, and that is how it should be. The speed of a car or that of an object should not depend upon how many frames the game is running at. It should always be constant, and delta time enables us to do just that. So the speed of the car would go from 5 pixels per frame to 5 pixels per second. Now I hope that is clear, and I'll also demonstrate why we should use delta time in a practical example by using the code that we just developed. Okay, now inside our code, if we remove the delta time multiplication inside our right key handling and left arrow key handling, let's see what happens if we run the game. Now we can see that the character of Mario is zooming past, because the speed of our Mario character is not just 200, it is being added, 200 is being added to our x position a total of 60 times if my game is running at 60 fps. So that is why we need to use delta time. Now if we do times delta time, now let's run the game again and see that the right position is working just fine, whereas the left position is zooming past. So that is why delta time is so necessary. Now okay, let's fix this, and since our character is not facing left and right, we'll achieve just that. Now we'll make our character flip horizontally when moving left or right, and this small detail makes the movement feel much more natural. First let's adjust our scaling, so 0, and let's make it a bit smaller, so 0.5 and 0.5. okay, now inside love.draw, let's add an if condition. So since we have made a player.facing_right variable already, we'll add an if condition. So if player.facing_right, then what we'll do is we'll just draw the player as it is, since our character is facing right on the default, and after that we'll go down and define an else condition. Else we will flip the sprite horizontally when facing left. Now we'll achieve that by using our scale value. So right now I just scaled my character down to a 50% its size. It works like this. If you don't know or if you haven't watched our previous videos, this is the character image or the character that you want to draw on the screen. This is its X position, this is its Y position, this is its rotation value, which we don't want to mess with right now, and this is its scale value. So this scales down the character to 50% of its original size. Now we'll use that scale to flip the character. So we'll do love.graphics dot draw player dot image, and then to compensate for flipping, we'll add some value to our X position value. We'll add the character width. So since I've scaled down my character to 50% of its size, we'll add 50% of its width to our character, and I'll explain why we do that and while we demonstrate our program. So 0.5 times our player dot image dot get, I mean not dot, colon get width, and after that we'll insert our player dot y value for our Y position, and then 0. Now normally for flipping I would do -1 and then 1, but since we have scaled down our character, we have to do -0.5 to flip our character horizontally on the horizontal scale. This is our scaling. The minus is for flipping, and then 0.5. Now that is essentially it. Now let's run our game and see how it runs. So right and left. See, Mario is turning left and right. Now why we added some value to our X position is because if we didn't do this, let's see what would happen. Oh, I didn't mean to close that, but okay. Now let's see what would happen. When we flip it, Mario would go all the way over here. Since it would flip starting from this starting position of Mario. So if we flip here, it would seem that Mario traveled a great distance when we flip left. So since we don't want it flipping inconsistently or like this, we add for that, or we compensate that by shifting our sprite by a factor of its width. So it'll look like it just stays in place and it flips. So when we do player.x plus player, let's say 0.5 times player dot image and colon get width, if we close this and run, then it'll seem like it just flips in place since we compensate for the flipping. So left, right, left, right. So that is how it works. So right now the player can walk right off the screen if he or she wants, and we don't want that. So let's fix that by clamping the player's position so that they can't go outside the game window. Now we'll do that by working with our love.update function. Okay, right now the player can walk right off the screen, so let's fix that by clamping the player's position so that they can't go outside the window. Now we'll do that by using love.update, and inside love.update, after this line, if love.keyboard is down right, then we'll use player x equals to, we'll use the math dot min method. So min player dot x plus speed, I'm going to type x plus speed times dt, and next our minimum value will be love dot graphics dot get width minus player, actually 0.5 times, since we have scaled everything down, 0.5 times player dot image and then get width. And we'll do the same inside all of the others. Now inside player dot is down, love dot keyboard dot is down left, we'll use math dot max. So math dot max, and inside math dot max we'll use player dot x minus speed times dt, and then 0. Now we'll do the same with our is down and is up. So I'll cut to that. Now as you can see, I have applied the same logic math.min and math.max to our is down and is down up as well. So after that, let's run our code and let's see what happens. So you can see that our character is limited on to our game window only. Now I'll explain the basic gist of this. Player.x.speed times delta time is where the player wants to go, but this value right here, our love.graphics.getWidth minus 0.5 player.image.getWidth, is basically our maximum x position allowed. Now you can do the calculation for yourself, but that is the basic gist of it. If our player speed or our player position increases than this maximum speed, what math.min does is it selects the lower value. So let's suppose our maximum values is 830, and if the player x position reaches 840, it will automatically clamp that value and pick 830 as our player position. So this will be essentially our maximum x position. And the same is with math.max, player x minus speed dt and 0. If our player, this is where the player wants to go, so if our left value goes on decreasing and reaches a minus value, so it will pick the maximum value in place of these two. So it will always pick 0. This is the minimum position of our x coordinate, that is the left edge. And if our player goes below that, that is minus, it will automatically clamp that onto our 0 position. And the same is happening in down and up, but instead of width, it is getting player height and screen height. So that is how you clamp your character onto your screen. So that was it for today. We managed to learn how delta time keeps the movement smooth and consistent across all computers. We switched from rectangles to sprites. We made the sprite flip depending upon the direction that we moved, and we clamped the sprite to stay inside our game window. So inside our next episode, we'll take it further and talk about how we can create walk animations or walk cycles where we can make our character walk. So make sure you watch that video. If you like the video, hope you drop a like and subscribe to our channel for more such videos. And until the next time, bye bye. Hey everyone, welcome back once again to the Love2D for Beginners series. Now in the last episode, we learned how to move objects smoothly on our screen using delta time. But right now, if we load a character sprite and move it around, it kind of just slides across the screen and it doesn't look alive yet. So in today's episode, I'm going to show you how you can make your character walk using a simple walk cycle animation. And we're going to do this using a really beginner-friendly technique, that is just by switching between separate images. No sprite sheets, no complex quads, nothing fancy. So this is going to be perfect for beginners. Now first, before we begin, let's quickly understand how animations actually work in games. An animation is basically a flipbook. When you switch between multiple images quickly, your brain sees it as a smooth motion. Now for example, if I have many images of a character walking, that is I have walk1.png, walk2.png, and like that multiple images, and I show them one after another really fast, it looks like the character is actually walking. And that is exactly what we're going to do today. We're going to load multiple images, we're going to switch between them automatically using a timer, and we're going to only switch when the keyboard input is active and when the player is actually moving. So let's get into it right away. And just a quick shout out, if you are learning Lua, you can check out our app on the Play Store, Lua for Games to Learn and Code. It is packed with interactive courses, fun coding challenges, and a built-in Lua compiler and step-by-step guides to build games like Brick Breaker. It is perfect for beginners who want to learn and practice Lua all in one place. So you can go check it out on the Play Store from Codin, Lua for Games, Learn and Code. Now let's get on with the video. Now for this video's example, I have actually downloaded these images from a website called itch.io. Now I'm going to be using 7 images. Those are walk 1, 2, 3, 4, 5, 6 and 7 for my walk animation cycle. And as I mentioned just now, I have got these from this website called itch.io. I just searched walk cycle and went to game assets and searched for the assets of my liking. And you guys can do the same after watching this video if you want to try out your own animation cycle. And links in the description will be given for this and this. That is the handsome cab walk cycle. Shout out to the authors Fenris and Pedro, and this sneaky walk which I have prepared just now to show you guys. I'm not sure how much of it is really visible, but I am pretty sure you can see this. Now we're going to be doing this. We're going to take our user input and flip through these images to make it seem like this is walking. And this is basically what we're going to be doing today. Now for our example, like I mentioned before, I'm going to be using this handsome cab walk cycle. And without further ado, let's get started with coding. Okay, I'll first of all open my VS Code, close this down, and keep this on the side. Actually, we can just maximize this window and later we can run our batch file. So I'll increase the size for you guys so it's easier to see. Now inside our main.lua file, let's first set up a simple player table with movement speed and frames. So we're going to create a local player, and this will be our table. And inside our table, we'll be working with speed. So let's create our speed variable, it's 200. And we're going to be using local frame time equals 0.1, and this is basically how much each frame, that is our each image of our walk cycle, should last. So each image should last 0.1 seconds, so time per frame in seconds. And then local will also count how much time has passed since the last frame. So we'll create a elapsed variable. So local elapsed equals 0 for now. And this tracks how much time has passed. Okay, now for this, let me explain real quick. This stores everything about our character, and our speed defines how fast our character moves. I have shown the use of the speed variable in episode 6 as well, that is our previous episode. If you're confused and want to learn from the basics, you can watch that episode as well. Link will be in the description. Now, local frame time will equal to 0.1, and this is how long one frame of animation should last, and by this value, there will be 10 frames per second. And elapsed is a timer which we can use to track when we need to switch between one image from the other. And okay, after this we'll create love.load function love.load, and inside love.load we'll create a table called player.frames to store our each individual frame. Now inside it we'll use love.graphics.newImage, and we'll name it walk1.png all the way to walk7.png, since that's how we have stored our images. Now make sure you have stored these images in the folder that contains the main.lua file. Now after that we use love.graphics.newImage. Actually, let me just copy this line all the way down. So 1, 2, 3, 4, 5, 6, and rename all of these. So, and after that, we are done with our player.frames table. We'll define a player.currentFrame. This is our key for our player table. So player.currentFrame equals 1, and we'll start with our first image, of course. So this will be 1. And player.x, our x position, and player.y, our y position, will equal to 100 at the beginning. And after that we'll define a variable called player.facingRight. So this we will basically be using to flip our image further in the future, I mean later in the video. Now we'll end our love.load, and next we'll define the animation using love.update. So we'll handle both our movement and frame switching inside love.update. So function, I'm sorry, I meant to type out function love.update dt, Now I have explained why we use our dt variable inside our episode 6 as well. So if you want to learn the logic behind why we use love.update dt, why we multiply our speed value with our delta time value, you can go check out episode 6. I'll not be explaining that in detail. I'll just be writing out the code and explaining the basics. So love.keyboard dot is down will use when the keyboard right arrow is down, then we will add on to our player.x value. So player.x plus speed times delta time. Now inside love.update, most of our functions will be, or most of our if conditions will be as before. So again, we'll do player, I meant to type out enter, player dot facing right will set it to true, since when we press our right button, the player or the character should face right. So this will be true. And if our user is entering or pressing any key, the movement should be true. So we'll set a moving value to true. And the default value of moving will be false, since if the user is not pressing any keys on the keyboard, the character should not move at all. So we have inside love.update, which updates every frame, we have set the default moving value to false. Now when the player is actually pressing the keyboard, we should set the moving value to true. Now I'll define these if conditions for basically all three of the remaining arrow keys, that is left, up and down, and I'll resume the video after I do that. Okay, and I am done with completing the rest of the code. I have basically handled the keyboard input left, down and up. So when the player presses down, the Y position is updated down and up, and when the player presses left or right, the X position of the player is updated with plus and minus. So that's basically the gist of it. And now we'll handle the logic of moving. So if moving, we will switch the animation frames. So if moving, then that is when the player is pressing down something on the keyboard. If moving, then our elapsed value will update with adding delta time. So elapsed plus delta time. Now since delta time is actually the time period between two individual frames, we'll know how much time is elapsed by adding the delta time value. So after adding delta time, if our elapsed value is more than or equal to how much our frame should last, so we have defined frame time, since each frame should last 0.1 seconds. If the elapsed time, or if the time between two frames is more than or equal to 0.1 second, we will have to switch the frame or switch our image. So then our elapsed, first of all, will reset to 0, and then we'll do the switching part. So we'll do player.current frame. So remember that our default, that is a current frame, our player.current frame was set to 1. That is our first image. We will have to cycle through all of these images. So what we'll do is we'll do player.current frame equals, we'll update the value. So player.current frame will use the modulus and the length of our player.frames table, that is our total frames, plus 1. Now what will happen is if our player.current frame is at 1, it will use the modulus, that is 1 modulo 7 is still equal to 1, and it will add 1 to the value. That is, it will iterate through all of these frames one by one. Now if our player.current frame reaches 7 modulus 7, that is our length of our player.frames table, 7 modulus 7 will equal to 0 and plus 1, which will equal to our first frame. So after our 7th frame, it will cycle back to our first frame, and after that we will exit out of this if condition, and then we'll define an else condition for when the player is not moving. So else, if the player is not moving, that is if the user is not pressing anything on any arrows on the keyboard, we'll switch the current frame back to 1, and this is the idle frame when standing, let's say, and then we'll end the if condition and then end the function. So that is basically it for defining the logic of movement and animation. Now we'll draw our character onto our screen by using love.draw. Love.draw will use local image equals player dot frames, and inside player dot frames we'll access player dot current frame, and after that we'll define a condition, that is if player is facing right, then we'll draw it as love.graphics.draw. We'll draw the image and we'll draw it at player.x position and player.y position. And basically the image is quite large, so I have to scale it down. So this is our rotation value, which will be 0, and this will be our horizontal scale, that is x scale value. I'll scale it down to 40% of its size using 0.4 and 0.4. And after that we'll define an else condition. Else, that is if the player is not facing right, if the player is facing left, we'll flip that image using the same graphics.draw logic. So player dot x plus 0.4 times the width of our image, so img dot get width and then after that we'll use player y. This is our y position, and the same 0 rotation, but instead of 0.4 we'll do minus 0.4 to flip the image, so minus 0.4. Now this will flip the image in place, and then 0.4. Now if you're wondering why we are adding the image width onto our x position, adding image dot get width fixes the drawing offset, so it won't look choppy. It will look like it just switches direction in place. So after that we'll end this condition and then end our function. And I would say that was it for our code, but I did notice while executing the program that I have written love.draw and not love.draw, and here it should be image colon get width. So and that is it for our code. Now let's execute our program and see if it works properly. So we'll run, and we can see that it looks pretty smooth. So that is how our walk animation cycles work. See, it is flipping through those 7 images, and when I stop moving, that is the keyboard input, it switches back to our first image, and our flipping left and right logic is working properly as well. So that was it for this video. To quickly recap, here's what we did today. We learned how game animations work like a flip book by flipping through all of these images one by one, and we loaded multiple images, that is these images, onto a table. We used the timer to switch between images every 0.1 seconds, and we updated the frames only when the player is moving. And not only that, we also flipped the player image according to the user input, that is when facing right or left. So this is a super beginner friendly way to add animations without touching sprite sheets or quads. Now in the next episode, we'll be handling the physics aspect of Love2D, that is we'll be dealing with collision detection basics. So hope you guys found the video helpful, and if you liked the episode or found it helpful, please drop a like, subscribe to our channel for more such videos and tutorials, and hope you guys don't just follow this tutorial. You can try out all of these characters if these are free, and with proper credit you can try walk cycles and animations on your own. And until the next episode, happy coding and bye bye. Hey everyone, welcome back to our Love2D for Beginners series, and in this episode we're diving into something super important for almost any game, that is collision detection. Ever wondered how games know when your character bumps into a wall or picks up an item? Well, that is collision detection. And today we'll learn a basic and popular method called AABB, which stands for Axis Aligned Bounding Box. So let's get right into it. So before we code, let's understand the concept of collision detection. Collision detection is how a game figures out whether the two objects are touching or overlapping. And there are many types of collision detection, but we'll start with the easiest and most useful, which is, as mentioned before, AABB. That stands for Axis Aligned Bounding Box. It's just a fancy way of checking if two rectangles overlap, and it works great for things like platforms, players, enemies, and walls. So let's set up our scene. We'll now open our main.lua file and define two rectangles, one static and one that we can move. So we'll open our VS Code now. And just a quick shout out, if you are learning Lua, you can check out our app on the Play Store, Lua for Games to Learn and Code. It is packed with interactive courses, fun coding challenges, and a built-in Lua compiler and step-by-step guides to build games like Brick Breaker. It is perfect for beginners who want to learn and practice Lua all in one place. So you can go check it out on the Play Store from Codin, Lua for Games, Learn and Code. Now let's get on with the video. Okay, now as mentioned before, let's define two rectangles first, one static and one that we can move. So first function love.load, we will create a player, and in this we can write its x coordinate. This is a player table, so our x coordinate, our y coordinate equals 100, our width of the player which will equal to 50, height of the player which will equal to 50 as well, so it will be kind of a square, not kind of, it will literally be a square. So speed equals to 100 since our player can move. And after that we'll define a box table, and this will have the properties of x equals 300, y equals 100, and width equals 100, and height equals 100 as well. Now we'll end the function, and after defining our player box that moves and a box that stays still, we will draw them. So function love.draw, we'll first select a color for our player which will be blue. Graphics.set color, I meant to do set color. Inside that we'll use an RGB value, so let's say 0, 0.5 and then 1 for blue. Now after that we'll draw the player, so love.graphics.rectangle, the rectangle will be filled and it will have the position values of player.x and player.y, a width of player.width and a height of player.height. After that we'll define our box, so love.graphics.setColor will define a different color for our box which will be red, so it will be 1, 0 and 0 for the RGB values. And then love.graphics.rectangle, once again it will be filled and it will have the coordinates of box.x and box.y, similarly box.width and box.height. Now we'll end our function, and if we run our game right now, we'll be able to see that we have defined two boxes, one for our player and one for our actual box. And after that we'll move the player using our arrow keys like we did earlier. So for that we'll be using the love.update function, and function love.update dt if love.keyboard.isDown right, that is if our right arrow key is pressed, then player.x should increase, so player.x plus speed times dt, which stands for delta time. And if you're unfamiliar with why we are using delta time in addition to using speed, you can check out our previous videos. It is basically to balance the speed of our objects according to time and not according to frame rate. And if that explanation wasn't clear enough, we have explained in detail in previous episodes, namely episode 6, so you can go check that out. Link will be in the description. So as if our love.keyboard.isDown is down, and that is left. That is our left key is pressed, and then the player dot x, that is the position of the player, should decrease. That is the x coordinate value should decrease if the player presses left. So player dot x minus speed times dt. Now similarly, we also have to define conditions for our up and down arrow. Now I'll not type all of it out, I'll skip to that part when we have typed it out. So I have completed the code, and what I noticed was there should have been player.speed instead of speed when I typed it out, and I have corrected that in all of the places. So what I did was I just updated the y values instead of the x values when the user presses up or down. So since the y coordinate should update, I updated that y coordinate. Now if we run our game and see, we should see the blue square should start moving when we press the arrow keys. Perfect. Now what we have to do is we have to detect when this square, the blue square, touches the red square or passes it. So we'll be doing just that. So it is time for the heart of this video, the AABB function. So it checks if two rectangles overlap using their x, y coordinate and height and width. So basically the gist is we'll be checking for 4 conditions. So in order to check if the two rectangles have collided or not, that is if our player and box have collided or not, we'll check for 4 conditions, and we'll be doing that by using their x and y values, x, y, height and width values. So we'll be checking if these two rectangles overlap using their x, y, width and height values. So first of all, if these two rectangles touch or overlap, they should be fulfilling 4 conditions. That is, the left edge of the rectangle, first rectangle, should be on the left side of the right edge of the second rectangle. So it should not be like this. The left edge should not be on the right side of the right edge of the second rectangle. So that is one condition. The next condition is the left edge of rectangle 2 should be on the left side of the right edge of the first rectangle. So this should be on the left side of this. So it should be like this at least. And the top edge of the first rectangle should be above the bottom edge of the right rectangle. So this is for checking like vertical collisions as well. This should not be true. The top edge of our blue rectangle should be above the bottom edge of the red rectangle. So this condition should also be fulfilled. And the last condition is the top edge of the red rectangle should be above the bottom edge of the blue rectangle. So like this. So those are our 4 conditions, and we'll be defining if the collision happens or not based on those 4 conditions. So let's get to coding. Now we'll create a function called check collision. So check collision, and we'll be inputting our x1, y1 values and width 1 and height 1 values. These are for our players, and x2, y2 and width 2 and height 2. And we'll be returning true, that is return if x1 is less than x2 plus w2. Now what this means is x1 is the so x1 is the starting position or the left edge of our rectangle, and what x2 is, it is the left edge of our red rectangle. But if we add on its width, it will be the coordinate of the right edge. So this basically means that the left edge should be on the left side of the right edge of the red rectangle. And I'll be defining all of the conditions mentioned before. So x2 is less than x1 plus width 1, and y1 is less than y2 plus h2. Now similarly, y2 is the starting or the top edge of our red rectangle, and if we add on its height, it will become the bottom edge. So this basically means that the top edge of our blue rectangle should be above the bottom edge of our red rectangle, and all of these must be simultaneously fulfilled, and that is why I'm using and y2 must be less than y1 plus h1, and that is basically the end of our conditions. And after that, we'll be using this function in love.update. So inside love.update, after we have fulfilled these, we'll be doing if check collision, and then inside player instead of x1 y1, we'll be entering player.x, player.y, player.width, player.height, and then the x coordinate of the box, the x coordinate of the y coordinate of the box, and similarly the height and width as well. So width and height. So if this condition is fulfilled, that is if it is overlapping, then let's say we print out collision onto the console. Collision. Now, not only that, we can also add a visual reaction. For example, we can change the box color while colliding. Now, inside love.draw, we can use set color to our advantage. So let's say, first of all, after we define our player, we say if check collision, and then we enter all of this. So I'll just copy. Then, okay, I didn't mean to copy this. So if check collision is true, that is if our rectangles have collided, then we can change the color of our red rectangle. So let's say love.graphics.set color, it will be green, so 0, 1 and 0, and else it will just be red, so else it will be red and will end. Now that is how we will check for our collision. Now let's run our code and see. So so you can see that when our blue rectangle, that is our player, touches or crosses the box, the immovable box, our box turns green. So our collision detection is working just fine. And that was it for this video. We learned what AABB collision is, and how to detect a rectangle overlap, and how to react when a collision happens. We've just added one of the core mechanics found inside thousands of games. Now before wrapping up, here's a quick challenge for you. You can try adding another rectangle, maybe an obstacle or another item, and check for collisions with both boxes separately. You could also make the second box move when the player touches it, so you can update its position values if the player touches it. That is some physics, and we can make the player stop moving when they collide as well. And don't worry if it is a bit tricky. Experimenting is how you'll really understand how collision works. And if you complete it, do share your code in the comments. I'd love to see what you came up with. In the next episode, we'll be adding sounds and musics to your game, so your game not only looks interactive but sounds interactive as well. If you like this episode, please drop a like, subscribe to the channel for more such videos, and let us know in the comments what kind of game are you planning to make with Love2D. And until the next one, happy coding and bye bye. Hey everyone, welcome back to Love2D for Beginners series. Today we're adding one of the most powerful tools to make your game immersive, that is sound. We are adding sounds. And by the end of this episode, you'll know how to add background music, trigger sound effects, control volume, pause and stop sounds, and also organize multiple sounds for bigger projects. So let's dive right in and make your game come alive. First, let's prepare our sound files. So Love2D supports OGG, .ogg, .wav and .mp3 formats. And here's a pro tip: you can use .ogg for looping backgrounds and for background music, since they have a smaller size and efficient streaming. And you can use .wav for short sound effects, because they have better quality and faster load. And meanwhile, .mp3 you can use for cutscene intros, basically background music that you don't want to be repeating. You can use mp3 for that. Now let's organize our files neatly inside a sound folder inside our game folder. So your project folder should be looking something like this. Inside your project folder, in which you have your main.lua file, there should also be a sounds folder in which there are sounds that you are going to be using inside your game. And after that, you can grab free sound assets from websites like freesound.org. For now, I have used Electronic Fluids by Light Mister. I'm just giving them credit for them. I'll even link these down in the description if you want to use them. And after that, I'm going to be using Blip, something called Blip, and Blip 2. And remember that in our 7th episode, we created a walk cycle where we created something with a dinosaur horse carriage. Well, I'm going to be adding sound to that as well with this. So let's get on with the video and start coding. So I'll be opening these two, and then for coding I'll just maximize this and start with our function. So to play sounds, we have to first load them using source objects. Now think of a source like a music player. It knows how to play, pause and stop one specific sound. So first we'll use function love.load in order to load our sounds. And then for our short sound effect, it should be loaded into the memory. And we'll use something called sound blip, and we'll use the blip audio. So love.audio dot new source. What was our source? Our source was sounds, our sounds folder, and inside our sounds folder, blip1.wav. This is our file format. And after that, we'll write our loading modes for our audio when we use that audio in our game. So it can either be static or stream. So first we'll be typing out static, since it is for a sound effect. So inside our quotes, we'll type out static. And then after that, we'll load our background music. So background music. So it is streamed from disk to save memory. After that, we'll use bg music equals love.audio.new source, and inside that, sound/bgm.ogg, and we'll be using our stream method. After that, if we want to loop the background music forever, so music, we'll use bg music set looping to true, so it will keep looping. And after that, we'll play the music. Okay, what? Okay, I meant to type out true. Okay, turns out it is auto completing, so true. And after that, bg music will start to play the music, so play. And if we end this and execute our code, so let's put this to the side and let's execute. We can see that our background music starts to play. I don't know if this is recording. Okay, it is recording, hopefully. So that is how you can play your background music. Now inside this, when we use love.audio.newSource, we have to write the source of the sound that we're going to be using, and then the loading method of the sound. Now static is good for short, frequently used sounds, whereas stream is better for long tracks like music. And if we set looping true, the background music will start looping. And if we use busy music, that is the source objects, busy music :play, the background music will start playing. And I'll remove this since I don't want the background music to play every time that I demonstrate the code. And after that, we'll be moving towards playing our sound effects. So I'll create a function love dot key pressed, and inside it I'll be using the key parameter. And if our key is space, let's say we want our character to make a sound or a blip sound when we press space. So we'll first use stop, so that if any music regarding our sound blip is playing, we will stop. So stop if already playing, and then we'll play our sound once again. So play. Now after that we'll end our function. Now inside our love.keyPressed key, when we use stop before our play, the sound restarts instantly, which feels more responsive when players can spam actions. Now let's play our game or run our Lua file once again. So when I press space, you can hear a blip. So this is me pressing space. Okay. Now that is it for playing our sounds. Now Love2D gives us full control over our volume and our playback, and the volume ranges from 0.0, which is silent, to 1.0, which is maximum. So you can set the initial volumes before you use them. Now to demonstrate this, I'll be using love.update, and inside love.update we'll use function love.update and use the dt, and we'll create a variable called local current volume, and it will be background music, and we'll use get volume. And let's say if that volume, unless that volume is more than, until that volume is more than 0, then we'll use background music dot set, colon set volume. We'll set our volume to current volume minus 1% of dt. So 1% dt. Now we'll use end, and then end our function as well. Now if we set this background music to playing once again, and let me just make this 0.2 so that we can see the effects faster, and we open our Lua file, we run our Lua file, we can notice that our background music's volume will start to decrease until it reaches 0. So it has reached 0 already while I was talking, pretty fast. So that is how we can use get volume and set volume to our advantage. Now this gradually fades out the background music over time, which is great for game over or scene transitions. Now after learning about set volume and get volume inside Love2D, let's learn about a method called pause. In Love2D, the pause method is used on an audio source object to temporarily stop playback while remembering where it let off. So when you later call play on the same source, it resumes from the paused position instead of restarting the whole sound. So let me break it down by writing some code. Inside our love.load, we'll start our background music and set it to looping. Now, and inside our love.keyPressed function, we'll change our key to p, and then we'll define some conditions. So if our background music is playing, so we'll do is playing, then we will pause the background music. So we'll use the pause method, or else we will play our background music. So we'll use colon play. Now this will resume from where it paused, and we'll remove this sound blip, and this will be our function. Now let's say comment this out at first, and let's start our program. So We'll run, we'll hit P, and then we'll hit P once again. So you can see that it continues to play from where we paused it. So let's see what will happen if we use stop instead of play. So when you use stop and then run our program once again, let's close these. Okay, I hit P, it stopped playing. See, it restarts the whole sound altogether. So that is the use case of pause. Now after that, let's learn about how to manage multiple sounds. As your game grows, managing sounds individually gets messy. A better way is to create a sound manager. And for creating a sound manager, I'll start from scratch. So first of all, I'll create a sounds table. Now you can do this inside love.load as well, but since I'm only displaying a few sounds, I'll just use a table outside love.load. So blip equals love.audio.newSource, and once again we'll use sounds. Okay, let's use blip2 this time. So blip2.wav. After that we'll use the static mode, and after that we'll create a BGM key, background music. So love.audio.newSource sound slash background music.ogg, and we'll use stream. And after that we'll use a function, okay, horrible spelling for function, a function called play sound. So play sound, and inside this we'll pass the name of the sound. And let's say if sounds contains the name, so if our name key, then we will first of all play that sound. No, first of all we'll stop that sound in order to prevent overlapping, and then we will play that sound. So play, and then inside our else condition, if our sound is not there, that's if the sound name pass is not inside our sound table, we'll use print to indicate that sound not found, and we'll indicate which sound was not found. So concatenate our name, and that's it for our function. Now when we call it, call play sound, and let's say we call background music, this should be inside quotes, I'm sorry. Okay, now after that if we execute our code, we can see that our background music is played. Whereas if we type in here blip, let's see what is played. See? So that is how you can manage your sounds. Instead of managing 10 plus variables, you can just call play sound and just pass the name of the sound you want to play, and it works. And that was it for this video. But before the video ends, let me demonstrate how you can use sounds inside Love2D efficiently with our code from our episode 7. Now inside our code from our 7th episode, I have loaded a horse sound with horse.mp3 loaded inside horse variable, and if moving, if our character or if our horse carriage is moving, we have played the sound, and if not moving, we have stopped the sound. So simple as that. Let's see how the output turns out. So we have our dinosaur horse carriage. Once again, shout out to its authors. I'll link this down in the description. But if we play this, you can see that it'll start playing the audio as well as it is animating. So pretty cool. And yeah, that was it for this video. Now your games don't just look fun, they sound fun too. And next up, we'll learn how to make a simple game called Pong in our next episode. So if you want to create a real game with all of the stuff that we have learned so far, don't forget to like this video, subscribe, and hit the bell icon so you don't miss it. Until the next time, happy coding and bye bye. Hey guys, welcome back to the Love2D for Beginners series, and today we're doing something exciting. We're recreating the classic arcade game Pong, and this is what our game will look like after we are done with it. So it'll be this with sound effects as well, and with a score system as well, and after, you know, it'll be this. So both of these paddles will be controlled by the player, and we have sound effects as well, and responsive movement and score tracking as well. So it'll be really fun. So what are we going to do in this episode? In this episode, we're going to set up our game window. This will actually be a three-part series in which in this episode we'll just set up our game window, we'll create the paddles and the ball, and we'll draw them on the screen. So by the end of this video you'll already see the foundation of the real game, and with that being said, let's dive right in. And just a quick shout out, if you are learning Lua, you can check out our app on the Play Store, Lua for Games to Learn and Code. It is packed with interactive courses, fun coding challenges, and a built-in Lua compiler and step-by-step guides to build games like Brick Breaker. It is perfect for beginners who want to learn and practice Lua all in one place. So you can go check it out on the Play Store from Codin, Lua for Games, Learn and Code. Now let's get on with the video. Now first what I'll do is I'll create a new game folder called Pong. I'll open it in command prompt so that I can open it in VS Code by typing CODE space dot. Now this will open the folder in VS Code. Let me maximize this and increase the size so that you guys can see clearly. And I'll create a new main.lua file, and inside this I'll start with our code. So first of all we will use a love.load, and inside love.load we will set the window title. So window.set title, we'll set the title to Pong game, and after that we'll set the width and height of our window. So love.window dot set mode, and inside set mode we'll use 800 and 600 values. Now this is our width times our height. Now we'll end the load function for now, and inside our load function, after we define our window size, we will define our our variables. So we will first define the constants related to our paddle and ball. So paddle and ball constants, and for that we will define our paddle width. So let me type this in all caps, paddle underscore width. So this will be 20, and then our paddle height. So paddle height, HIEGST. I forgot a second for the spelling of white. So 100. After that we can type out the ball size. So ball size, let's say it's 20 as well. After that we will first define the left paddle. So this will be our left side's paddle will be player 1. So player 1, and we'll create a table for player 1, and inside the table we'll define the x and y values. The x value will be 50 and the y value will be 250. Let me enter a comma here and a comma here. After that we'll define the width, and the width will be equal to our paddle width. So paddle width, and our height will equal to paddle height. And after that we are done with our player 1 table. Then we'll create a table for, okay, didn't mean to do that. Then we'll create a table for our right paddle, and that will be for our player 2. So player 2 will equal to x position being 800. So this is our full screen width, minus 50 minus our paddle width. So it should start from there, so I'll be using our paddle width over here, paddle width. And as for our y position, it will initially equal to 250 as well. So y should be small, equals to 250. Okay, for some reason I always forget the commas, and after that we'll be defining its height and width, and for that I'll just copy this and paste this. So height and width will be the same for player 2 as well. Now we're done with our paddles. Let's define a table for our ball. So ball. Now for ball equals for its x position, we'll be placing this at the middle, so 400 minus our ball size by 2. And then as for our y position, it will be, let's see, 600, so it will be half of that, 300 minus our, this is the center of the ball, so this position is for the center of the ball, so ball size by 2. Now we want the ball to be at the center, dead center of the screen at the initial position, so that's why I'm defining the half height and half width and half height of our screen over here, and this is to center the ball. Now after that, now I'm pretty sure that you know that Love2D's coordinate system starts at 0 0 at the top left corner, and if we increase the x value it will go right, if we increase the y value it will go down. So I hope you know that already, you have been following this along. And now let's make our paddles and ball visible by using the love.draw function. So okay, my caps lock is on, function love.draw, and inside this we will not have to set our background color that much, but let's use the set background color. So we'll set our background color to a bit more than, I guess, less black. So love.graphics.set background color will do 0.1, 0.1 and 0.1. This won't make a lot of difference, but let's just leave it out here. After that, we should draw the dashed line at center. So for that we'll use love.graphics, we'll use our white color, so love.graphics.set color, we'll use 111, this is for our white color. And to draw a bunch of rectangles as our dashed line, we'll use a for loop. So for I equals 0 to 600 with a difference of 30, do love.graphics.rectangle, as I said, we'll be drawing rectangles for our dashed line. Those rectangles will be filled, so fill. And then our width, so it will be 395, and no, not our width, our position, our x position will be 395. For our y position it will be the value of I, and for our height and width, width and height, then it will be 10 and 10. No, let's do 15, otherwise it will not be actually a rectangle, it will be a square. And as for drawing our paddles, so draw paddles, we'll do love.graphics.rectangle, fill. Now because the first paddle should be for player 1, we'll be using player 1's table. So player 1 dot x will be the x position, player 1 dot y will be the y position, player 1 dot width will be the width, and player 1 dot height will be the height. And that is it for our player 1. As for our player 2, we'll use the same line. Let me just copy this, and 2, player 2, player 2, and one last time player 2. After that, we are done with drawing our paddles. Let's draw the ball. So draw ball. Love.graphics dot rectangle. Our ball will be a rectangle as well. It will have the fill method. Okay, before drawing the ball, let's see if our our paddles have been drawn or not. So for executing this, we will create a batch file. So let me just copy this batch file from our previous episodes onto our new folder. So it was Pong, right? So yeah, this is essentially a batch file which, okay, we have drawn our paddles, we have not moved them yet, and as you can see, we have drawn our dashed line as well. So as I was saying, the batch file is essentially just it just contains the location of our love.exe and then a pause to pause. So we have drawn our rectangles. Let's not include our end statement, since we have left to draw the ball as well. We'll be drawing our balls after we'll be drawing after our ball after we drew the paddles. So ball.x, ball.y, and the ball width. So we'll not use width, since we have defined a size for our ball. Oh, we haven't defined a size for our ball, my bad. So as for our size, it will equal to ball size, which we have defined up here. So we'll use ball.size and ball.size once again. Since we want it to be kind of a square, it would look like a rectangle. So that was it. And after that, we'll write end, and we'll end our draw function. So here's what's happening. We have set our color to dark, our background, but even if we did not do this, it would default to a dark background, so you don't really need to do this. And after that, to draw the dashed line, we used a for loop, which drew the dashed lines at the position. Now we are altering between 0 to 600, which is the total height of our screen. As you can see, 600 will be our height of our window. So from 0 to 600, we have drawn mini rectangles at a difference of 30. So 0 is here. Okay, let me just execute the code and show you. So where was it? It was in Pong. So 0 is right here, and after a difference of 30 up and all the way until 600, we have drew these dashed lines, which are essentially rectangles, to create a dashed line. And this rectangle, or let's say a square right here, is our ball. Even with simple shapes, it already feels like a game. Now, since this is really less for our episode, I'll throw in an extra bit where we can move our players, player 1 and player 2. So for doing that, we'll have to use the love.update function. So we'll write function love.update. Inside this, we'll use dt. And after that, we'll define a speed value, since we want to move them by a certain speed. So this you can consider pixels per second. So it's 300 pixels per second. And in that, we'll use love.keyboard.isDown to detect player input. And let's say for player 1, we control it using W and S. So if the player presses the W, then the position, especially since W is a point, in typical games, W corresponds to up, the player position, specifically our Y position, should update. So since it should move up, the player's Y position value should decrease. So player 1.y value should decrease, and by how much should it decrease? It should decrease by a fold of our speed times dt. And after that, use else if our love.keyboard.isDown is equal to S, that is for down, then we have to increase the player Y position value. So player dot Y, a player, not just player, actually it should be player 1 here. So player 1 dot Y we should increase. So player, what is with my fingers today? Okay, player 1 dot Y will increase speed times dt. So this is updating the player paddles, this paddles position. So when I press S, it should go down, that is its Y position value should increase. So that is why we are increasing the Y positions value right here. Now after that, it is the end for this if condition. Let's end our function as well, and I'll close this for now. Let's see if our paddles are moving, specifically this paddle. So you can see that this paddle is moving as well. Now in order to move this paddle, we can use the same logic, but instead of W and S, we can use our up and down arrow. So up and down. So let's close this and execute our code once again. Oh, I meant to type out player 2. So if I press up and down, the player 2, that is our second right paddle, should update. Okay, this should be player 2 as well. My bad. Okay, our player 1 and 2 are moving nicely. Now that is it for our episode. We are multiplying our player 1 and player 2 values by speed and dt. We are subtracting and adding speed times dt onto our player values, and that is how they are moving. Now in the next episode, we'll cover our ball physics and collisions, and even set up a small point system. So I hope you stay tuned for that, and I hope this episode was helpful. If you liked the episode, drop a like and subscribe to the channel for more such videos. And until then, bye bye and happy coding. Hello everybody and welcome back to our Love2D Pong series. Now in part 1, we set up the paddles, the ball, and we drew those paddles and the ball on our game window. But since the content felt a bit short, I also included the logic for movement of the paddles for player 1 and player 2. And today in part 2, we'll make the game come alive by including these features. So first, we will add ball movement and bouncing around, the wall bounces of the ball. And next, we will also add the interaction of the ball with the paddles, that is collision detection with the paddles. And finally, we will also be adding a simple scoring system to our game. So by the end of this episode, you'll have a fully playable Pong match, and let's jump right in. Okay, let's open up our project folder from our previous episode, and we'll open our main.lua file in this. And this is the code from our previous episode, and we'll make some changes inside love.load since we have already included the code for the paddle movements in love.update. So inside love.load, up here, actually below our ball table, we'll include the initial speed for the ball. So ball.dx will equal to 200, and you can consider this the horizontal speed, and ball.dy will equal to 200 as well. This will be the vertical speed. Now in our game, we want the ball to move, right? And to do that, we need to control how fast it travels horizontally and vertically. Here ball.dx stands for delta x, basically how much the ball's x position changes every second. And since we set ball.dx to 200, it means that the ball moves 200 pixels per second along the x-axis. And similarly, ball.dy is for the y-axis. It's how fast the ball moves up and down. And later inside love.update, we will multiply these speeds by dt so that the ball moves smoothly and consistently no matter how fast the computer is. So we have loaded the speed of our ball. Let's make it move inside love.update. So for moving our ball, let's say move ball, ball.x should increase by ball.x plus our ball.dx times dt. After that, we'll use ball dot y equals ball dot y plus ball dot dy times dt, and that's about it. Now let's open our game and let's see how it moves. See, so it is moving, but it is moving diagonally and it is going off screen and not regenerating at all. So right now the ball moves diagonally in a straight line, and in order to make it not go off bounds, let's make it bounce off the walls. So for our bouncing all the walls logic, let's go to our code once again, and inside love.update, let's define a condition. If our ball dot y is less than or equal to 0, that is our starting position of the upper bound, then we'll do ball dot y equals 0, and in order to reverse its direction, we'll do ball dot dy, our speed, will turn it into minus ball dot dy. Now what this will do is, if it was going up, it will change the direction of the ball and it will go down. So ball dot dy. But else if our ball dot y plus ball dot size were to be greater than or equal to our maximum height, that is our 600, the bottom of the screen, then we'd have to reverse its direction once again. So we'll set our ball's position to equals to 600, but in order to show the whole ball to account for its size as well, we'll subtract ball dot size. And after that, we'll do ball dot dy equals, once again, if it bounces or if it hits the lower bound, we have to make it bounce off in the opposite direction. So we'll change its direction. So minus ball dot dy. Now that is it for our bouncing logic. Now we haven't accounted for our left and right sides. We have accounted for our upper and lower bounds. So let's see if our code is working. You can see that our Pong ball is bouncing off the wall. So once again, yes, it is bouncing off the wall. So that is successful for now. Now whenever the ball hits the top or bottom edges, we reverse its vertical speed and we also clamp its position to avoid visual glitches. Now for the fun part, making the ball bounce off the paddles. Now to check for the collision with a paddle, we have to create our own function called local function check collision, and we'll define our ball and paddle for our parameters. Now if you don't know about collision detection, we're going to be using the basic AABB, which stands for axis aligned bounding box collision detection, and we have a separate video on this channel on episode, I forgot the episode number, it was maybe 8. Yeah, you can go check that out. Link will be in the description. I have described about how this logic works. Right now I'll just be writing the code. So return, it will return true if 4 conditions are fulfilled. So ball.x and paddle.x plus ball.x position should be less than paddle.x plus paddle.width. This basically means the right edge of our paddle, and so ball.x plus ball.size should be greater than paddle.x, and ball.y should be less than paddle.y plus paddle.height, and ball.y plus ball's size, that is its width, should be greater than or equals to, actually you can add equals to in all of these in order to have better collision detection. So equals to, actually this should be less than or equals to, yeah, that's better. Now after that we'll do paddle dot y and then end. Oh, I didn't mean to use curly braces, I forgot. Now this is our function for checking our collision. Now inside love.update we can check for our collision. So if check collision, let's say ball and player 1, then we would have to prevent overlap. So ball.x equals player 1.x value plus player's width. So in order to prevent the overlap and just hit the ball at the paddle, we are adjusting the ball's position after our ball has collided with our paddle. So we are adjusting this for preventing overlap. And next, in order to bounce the ball in the opposite direction, we'll do what we did with the walls. That is, we'll reverse the ball's direction. So ball dot x, dx. And in order to increase the difficulty as the game goes on, we'll multiply the speed of our ball slightly. You can even change these values to increase the difficulty. So this will be to bounce and to speed up lightly. Now for our second paddle, we'll apply the same logic. So this will be player 2. And in order to use this, we actually have to define this above love.update. Now this will be in use. Okay, you can see. Now after that, we'll do player 2 and player 2 once again. And in this case, we'll subtract the ball's size. So not player 2, but this will be accounting for our ball's size. And that is about it. It should bounce off our paddles now. Now let's test our code and see if our paddles are working well. Okay, so our paddles are going off bound. We have to fix that. But oh my god. Okay, our ball is bouncing off our paddles, so it is successful. You can see that it's working quite well. Okay, I just missed that, but you get the gist. Now you might have noticed that when our ball goes off bounds, the game just kind of stalls because the ball is off bounds and you cannot play anymore since it doesn't respawn. Now we'll fix that by keeping track of our player's score, and for that we'll have to develop a reset ball function which resets the ball's position and starts the game again once one of the players scores. So we'll be doing just that, and for that we will have to initialize the scores inside love.load at first. So we'll do score 1. This will be the player 1 score. So score 1 equals 0 and score 2 will equal to 0. And after that, inside love.update, before using love.update, let's form a function called reset ball. So local function reset ball, and inside this we'll do ball.x equals 400 minus ball.size by 2. This is basically resetting the ball at the center of the screen, and 300 minus ball.size by 2. Now these two lines centered the ball at the center of the screen, but in order to define the moving pattern of the ball, we'll have to define its speed as well. So horizontal speed we'll set 200 once again, but instead of just writing out 200, we'll multiply it by our math.random, so that it does not just go in a singular direction, it randomizes between two directions. So once it respawns, it can either go towards player 1 or player 2. So for that we'll be using math.random. So let's keep this inside parentheses. So math.random will be using 2. So it will be choosing either randomly between the number 1 or the number 2, and if our math.random will equal to 1, we'll use kind of like a ternary operator. It's like an if else. If our random choice is ends up being 1 is equal to 1, we'll return 1. If not, we'll return -1. So it's like that, and or -1. So if it is 1, it'll return a positive value, it'll go towards the right. And if it is 2 in place of 1 or 2, it chooses 2, it will return a negative value, so the direction of our ball will be reversed and it will go towards left. So that is the basic gist, and we'll basically copy this line but for our y position value. So y, and we're good. That is basically our reset ball function. And now we'll be using this function inside our love.update. Inside our love.update, we'll do if ball.x plus our ball.size is less than 0, that is, it goes off bounds, then we will increase the score of our player 1. So score 1. Actually, wait, it should be score 2. I'm sorry. Since if it goes off bounds here, the player 2 has scored, so score 2. Score 2 plus 1, and after that we'll reset our ball. So reset ball. And as for scoring by our player 2, so I mean player 1, if say else if our ball.x is greater than 800, that is, it goes off bounds here on the right side of the screen, and then we'll increase the score 1. So score 1 plus 1, and then reset ball, and that's it. Now let's see our code for Pong. Okay, it is resetting, but our score is not being drawn on our screen. So our player score value is updating, and oh my god, okay, and the ball is resetting, but now we have to draw those scores onto our screen, and we'll be doing just that. Now for drawing the scores inside love.draw, we'll be including some code. Now first we'll include local score font. So let's select a font for our score. Score font equals love.graphics dot new font, and then 40, and love.graphics dot set font will do score font. After that we'll actually draw our scores. So love.graphics dot print score 1, and let's say it's at 350, and for our score 2 we'll draw that at, first of all let's slide score 2, and we'll draw that at 470, that is on the right side of our game window, and let's say the y position is same. Now you'll see the scores update whenever someone misses the ball, and you can tweak its positioning or center them later using get width for more precision. Now finally let's check our code once again. You can see that the scores will update now. So okay, let's miss on purpose. Okay, it is. Now we do have to clamp these parallels onto our game window, and we'll be doing that in the next episode, but this is it for our episode. So you can see that the scores are updating and the game is resetting as well, and it is resetting randomly, okay, 3 times in a row for this, and you can see that the directions are, see, it just went there. So this is it for today's episode, and the next episode we'll be polishing our game by adding a win condition, a restart condition, and some sounds and a little bit of tweaks as well. So don't forget to like the video if you found the video helpful, subscribe to our channel if you don't want to miss these videos, and hit the bell icon so you don't miss it. And until then, we'll see you guys in the next one. Thank you. Hello everybody and welcome back to the final part of our Pong game series. Now in today's episode we'll make our Pong game feel more alive by adding the following things. First, we'll add some sound effects to our ball when it hits the wall and someone scores. We'll also add the win condition for players, as in how many points does the player has to score in order to win. And finally, we'll also be adding a restart mechanism after one player has won the game. And by the end of this episode, you'll have something like this. And let's score first. So see, that will be our final product, and it will restart basically after 5 points. So let's get into making our game more lively. And just a quick shout out, if you are learning Lua, you can check out our app on the Play Store. Lua for games to learn and code. It is packed with interactive courses, fun coding challenges, and a built-in Lua compiler and step-by-step guides to build games like Brick Breaker. It is perfect for beginners who want to learn and practice Lua all in one place. So you can go check it out on the Play Store from Codin, Lua for games, learn and code. Now let's get on with the video. Now first, let's make our game more lively by adding our sounds to our game to make our game sound better. Now we'll add some sound effects for collisions and scoring. And inside your Pong folder, your project folder, you can create a folder called assets, and inside that assets folder, you can add 2 sound files. One for our bounce sound for hitting our wall, and next is for our score sound for when a player scores a point. Now shout out to these people right here, Allstorm, and the next is Little Robot Sounds. You can check these sounds out. I have gotten these sounds from freesound.org. These are the sounds basically, and I'll be leaving these links in the description so that you can access these sounds as well. Now let's open our main.lua file and let's get to coding. Now we'll load these sound effects inside love.load. Now after our scores, let's load our sounds. So load sound effects. And I know you guys have been asking for the source code. After this completion of the final part, that is this episode, I'll be leaving the source code in the description as well, so you can check that out when this episode airs. So first of all, let's load our bounce sound. So bounce sound equals love.audio.new source. We have stored it in assets / we have stored it as bounce.wav, and for our loading method we'll use static, since this will be a short sound effect. I should add a quotes here as well. And as for our score sound, we'll do love.audio.new source once again, and it's the same, it's assets since it is inside our assets folder, and then our score.wav, and this will be static as well, so static. Now after we have loaded our sound effects, we can go inside love.update and add these sound effects to their appropriate places. So inside our love.update, let's see. Okay, so when our paddle and ball meet, we have to hit bounce sound. So first of all, if our player 1 and paddle collides, then we have to write love.audio.play. Now if you're new to this series and this is your first episode, we have actually had 2 episodes before this where we have coded almost all the game. This episode is just for polishing the game, so you can check those episodes out as well. Link will be in the description. Now when our player and ball collide, we have to play the bounce sound. So I'll copy this and I'll paste this here as well, so that both paddles make a sound when colliding with the ball. Now when it hits the wall as well, so this is for our wall, we have to add the bounce sound here as well when it hits the wall. So I should have commented this part and made it clear. When the ball hits the wall. That kind of rhymes, okay. So first we'll play our sound, and then we'll reset the ball and reverse its direction. So here we'll add the bounce sound as well. Now as for our score.wav, that is our score sound, we'll add that when someone scores. So where was our score? So it was down here. That's right, we have increased the score, and after increase the score, let's play our increased score sound. So love.audio.play score sound, and the same goes for when the other player scores. Okay, we are done with adding our sounds. Let's check out our game and see if it is successful. See, okay, it bounces as well. Let's see if it scores. Okay, well, our sounds are loading quite well. Now let's get to the part of defining a win condition. So actually, before defining our win condition, let's make our score display clearer and more polished. So inside love.draw, where we have drawn our scores, so where is love.draw? Here is our drawn our scores part. So first we'll use, instead of print, we'll use printf, and basically the syntax for printf is like this. So love.graphics.printf, first we'll write what we have to print. So we'll print score 1 and 2. For now I'll write 1, and then our x position, then y position, and then the limit, which is the maximum width the text is allowed to take, and if it crosses that width, it'll start displaying from the next line. So that is our limit, and after that we have our align property as well. Now this is basically how your text is aligned according to the given limit. Now instead of these bland prints, we'll use love.print, I mean printf. So love.graphics.printf will print score 1 at first. Let's say it will display at 0, and then 50, 400. But instead of just starting from the top, left side of our x-axis, since we have put 0, we'll align it to the center, so it displays cleanly and neatly at the center. Okay, this should be in quotes. Center should be in quotes. That is why a yellow line was shown. After that, we'll copy this line and just change the position values and our score too. So this will be, let's say, no, not this. This will be 400. And now our scores will display neatly as well. Now, after that, let's not test our game immediately. We also have to add a winning condition. So for that, we'll have to define some variables at the top of our main.lua file. So even before function love.load, let's define, at the top of main.lua, and this is pretty evident visually as well, but we'll define a winning score. So let's say our player should win, either of the players should win after they have scored 5 points. So first we'll set a variable called game over to false, and if any of our player reaches this winning score value, we'll turn our game over to true, and that will basically be our game over. And for our winner, we'll set it to a default of nil, and inside love.update we'll add a check for if someone has won. So where's our love.update? This is our love.update, and at the bottom we'll add, no, not at the bottom, this should actually be at the top to see if someone has won or not. So love.update, at the top we'll see check if someone won. Now for that, we'll do if score 1 is greater or equal to our winning score, which has a value of 5, then as I said before, we'll turn our game over value to 2, and we'll set the winner, true, and we'll set the winner to player 1. Now, why we are defining a winner value, we have to display the winner on our screen as well. So for now, we are assigning it to assigning player 1 to our winner value. And else if our score 2 is greater than or equal to our winning score, then it's the same gist. Game over will be 2 and our winner will be player 2. And to draw our winner onto the screen, let's do inside love.draw at the top, we'll do if game over, that is if someone has won. Then we will first set the font. So love.graphics.set font, we'll do love.graphics.new font 36, and after that we will print out love.graphics.printf winner, that is our not capital, that is whoever has won, since we have defined winners for player 1 and player 2 inside love.update. So whoever wins will be printed onto the screen. Where was our love.draw again? So winner dot dot, that is concatenation operator, wins, and the positions will be 0 to 50. 800 will be the maximum width, and then it will also be displayed at the center. And now we also have to indicate the player to press R to restart the game after a player has won. So for that we'll use a smaller font, so we'll use 20, and then love.graphics, sorry for my sloppy typing, printf, we'll say press R to restart, to prompt the user to restart the game after someone has won. And after that we can display that at 0 and a bit below our winner display, so 300, and maximum width of 800 once again, and then it will be displayed at the center. So after that, after someone has won, we have to stop the game. So inside love.draw we'll add a return value. So this will be to stop the stop drawing pedals and ball when the game ends. Now as for our restart mechanism, we have to define it. Let's define it way at the bottom. So we have to restart our game when the player presses R. So what will we use? We'll use function love.keyPressed and key, and as we said before, the key should be our R key. And in order to prevent the game from restarting even when none of them have won, we have to pair it with game over. So only when the game is over and the player presses the R key, the game should restart. So then we'll reset our scores. Score 1 equals 0. Score 2 will equal to 0 as well. We'll have to write our game over false, and the winner will be no one. So winner is equal to nil. And after that we'll have to reset the ball. So reset ball will be used. And that is about it. But okay, here's some error. Okay, we didn't end our function. That's the error. And I think we defined this inside our love.update. Let's fix this real quick. So below that we'll define this. And one quick thing that I realized, in order to completely stop the game, we inside love.update, if someone has won, we have to use return so that the game stops completely. So return. Now if we execute our code, let's see what happens if we let someone win. So let's let player 1 win deliberately. So you can see that player 1 wins, and press R to restart, and when we press R, the game restarts. So that is how this game works. Now you might have noticed that our paddles go off bounds when we keep pressing W or S, and they can basically go off screen as well. Now in order to prevent this, we have a quick and simple fix. Now at the place where we simply update the position, we can use math.max, and inside math.max we can use 0, comma, player1.y minus speed times dt, and then below we can use math.min, and this will be 600 minus player1 dot height, and comma, player1 dot y speed times dt. This will be the same. Now let's test our game for player 1 and see if it is working or not. So you can see that our player 1's is clamped. Position is clamped. It does not go off bounds, whereas player 2 goes off bounds. So what math.max and math.min are basically doing is they are clamping the value of our player. So if this value goes below 0, it will automatically make the player y's position value 0, and if this goes beyond our screen height, so all the way down it is 600 position, and if it goes above 600, it will clamp the position of our player to this position right here, that is 600 minus the player 1's height. Now if we apply the same logic down below, we'll be able to see that our player 2's paddle is clamped as well. Okay, I'm done with updating our code here as well. Now let's open our folder and run our game and see if they are clamped. So you can see that both of the players are clamped to our game window. And that was basically it for this video. In this video, we have polished our game and finalized our game by adding some sound effects, applying win conditions, a better score display, and a restart mechanism as well. And what we were not able to do in our previous videos, we have clamped the paddles onto our game window as well. So that was the complete Pong game tutorial. If you like the video, drop a like, subscribe to our channel for more such videos, and we'll see you guys in the next one. Until then, happy coding and bye-bye. Hello everybody and welcome back to the channel, and in today's episode of our Love2D for Beginners series, we're going to make our game feel more lively by adding some simple animations. Now we're going to be discussing walk cycle animations once again. I believe we have done an episode on that in the past, but in today's episode, instead of using separate PNG images, we are going to be using what's called a single sprite sheet. And we're going to be adding simple animation, a walk cycle animation using frame by frame sprite animation in Love2D. And here's a quick preview of what our animation will look like. So this is our character right here, and we'll be making it walk like this, a walk animation, pretty smooth, and it walks left and right. I've not added up and down animations yet, but we'll be using this sprite sheet, so you can see that it contains different images of the character walking, the walk cycle, and I have obtained that from once again itch.io. Shout out to Ordinary Bumblebee. I've taken the walk cycle from this page right here. I'll leave this link down in the description, and you can use it out and test the code on your own as well. So let's get on with the video. Now, by the end of this episode, you'll know how to load a sprite sheet onto your game, slice it into different frames, and cycle through them smoothly with delta time, and animate the character that actually moves around on your screen. So let's dive right in. First of all, like we discussed in our previous episode regarding animation, how do animations actually work? Well, frame by frame animation works like a flipbook. Each page is a still image, and flipping through them quickly creates the illusion of motion. And in Love2D, we usually do this with something called a sprite sheet. It is an image that has multiple frames of an animation side by side, and we flip through them by slicing the image onto parts. So there are two main ways to animate in Love2D. First, it is by using something called quads, and it is a manual method, and the next is using libraries like animate, which can simplify things. Now, learning the manual method first gives you a solid foundation, so we are going to be discussing that today. Now let's jump right into our main.lua file. So I have here a folder called animation, and now let's be real, I just renamed the Pong folder to animation, and I have here our character.png, which is actually our sprite sheet. Now let's open our main.lua file and start with our code. So we will actually start, okay, let me just cross this and this. Now we will actually start with our function love.load. And inside love.load, we will create a variable called sprite sheet, and this will have our image. So love.graphics.new image, which will be our character.png, and after that we'll use our frame width and frame height. Now these are two variables, and in our sprite sheet each individual frame should have a definite width and a definite height. So in our case, each frame of our walk cycle animation will have a width of 32 and a height of 50. So after that, we'll define our player table, which will define the position of our player. So first of all, okay, let me hit enter. First of all, our starting position will be 100, x equals to 100 and y equals to 100 as well. And our player's speed at which the player will walk will be 100 as well. So after that, we'll have to obtain the size of our sprite sheet in order to work with it. So first we'll get the sheet size. So for that, we'll create two variables once again, so called local sheet width and our sheet height. Now this will be sprite sheet, which is loaded, in which our sprite sheet is loaded, and colon get dimensions. So with this, we'll have the height and width, width and height of our sprite sheet, and after that we'll create a variable called columns, which will be width divided by our sheet height. So this will give us the number of columns. And in order to slice the frames into quads, now I'll tell you in a bit of what quads actually are. We'll create a table. So first I'll write a small comment so for you guys to understand. So slice the frames into quads. We'll first create a table called quads. We'll leave it empty for now. And then we will run a for loop in which I will equal to 0, and it will run from 0 to our total number of columns minus 1. Now for each column, we will create a quad. So what is a quad? Let me write this out at first. So quads equals. So a quad is basically a window or cutout that lets you select a portion of an image. So since we want to select each individual portion of this whole sprite sheet, we'll have to use quads to select each individual portion. So instead of drawing the entire image, you can use a quad to say, I only want this portion of the image. And for that, you can use something called love.graphics.quad. And not just quad, new quad. So new quad. And this will accept our x, y. Now I'll explain all of these, width, height, our sprite width, and our sprite height. So first of all, x is the x coordinate of the top left corner of the frame inside a sprite sheet. So suppose we want to select the first frame, right? So the x position would be the top left corner of this slice right here, so it would be right here. This position's x value would be in our x value, and similarly, if you wanted to select the second frame, the x value would be updated by its width. So we would have to put in the x value of this slice right here. And the same is with the y value. The y value is the y coordinate of the top left corner of the sprite you want to select. So if your animation has a second row as well, y would be the row's starting pixel. And as for the width and height values, these are the width and height of the individual frame. So in place of width and height, we'll keep our frame width and frame height. This is how much your each individual frame should be wide and height. So in our case, it will be this width and this height. And as for our sprite width and sprite height, you can deduce from the name itself. It is the total width of our sprite sheet and the total height of our sprite sheet. So I hope that is clear, and we'll be using this in a way that follows. So inside our for loop, we'll be using our quads table, and we'll be basically populating our table at first. So this indicates the number. So since our quads table is empty at first, hashtag quads will equal to 0 and plus 1. So in our first index of our table, we'll fill love.graphics.new quad, and in place of x and y, we'll first write I times our frame width. So I times our frame width, and then 0 for our frame height, since our sprite sheet is only of a single line. So since our top left corner will be 0, 0, it'll equal to 0 times our frame width and 0 as well. And after that, as for our sprite width and height, we'll use our frame width and frame height. And after that, we'll use our sheet width and sheet height. Now after that, we'll end our for loop, and then after our for loop, we will create a variable called current frame, which will equal to 1 at first, since we have to start from the first frame of our quads table. So current frame will be 1. We'll also create a timer, which will initially be 0, and we'll create a frame duration. And this is basically how long a frame, each individual frame should last. So let's say 0.15. 0.15. Now this is seconds per frame. So each frame will last about 0.15 seconds, and we'll create a variable to flip our sprite from left to right. We'll create a variable called facing left, which we'll be using in the future, so false. And after that, we'll end our love.load. So inside our love.load, okay, I should put commas here. Now inside our love.load, we are loading an image called character PNG, like I've explained before, and this one has multiple frames in a row, each which are separated by 32 pixels. So 32 by 50 pixels approx. So these are separated by 32 pixels, and we grab the sheet's width, slice it into frames using love.graphics.new quad, and then load them into our quads table. So that is what is happening inside our love.load, and these are basically for cycling through our frame. So we have defined our current frame to be first frame at first, the timer to be 0, which we will be resetting after each frame, and our frame duration and our facing left value. So after all this, we have to cycle through our frames, and we'll be doing that using our love.update function. Now function love.update, we'll use delta time. And inside this, for our animation update, we'll be using our timer value, and to keep track of our time, we'll be increasing it by a value of delta time. So delta time is basically the time frame between two frames. So this will perfectly keep track of the time it takes, or it has passed between each individual frame. And as for our animation, if our timer is greater than or equals to our frame duration, that is how much each frame should last, then we will reset the timer at first. So instead of just doing 0, we'll be subtracting the frame duration value to make it more stable, and we'll create a variable. We'll use our variable, so which is called if is moving. So if our character is moving by our keyboard input, we will change our current frame. So current frame will equal to current frame modulus the total length of our quads table plus 1. So we have basically used modulus to cycle through each and every frame present inside our quads table. So after it has reached the last frame, it will restart from 1, since our last frame's value by the total length of our quads will equal to 0 and plus 1, which will restart it from our first ever frame. So that is how we'll be using our timer to keep track and update our current frame. Now we'll define at first the default is moving to false, and we'll only set is moving to true when we detect keyboard input. So as for our movement, we'll use if love.keyboard.isDown. So let's say we'll do right. So if our player presses the right arrow, then we will first of all turn is moving to true, so that our character animates. Will set facing left to false, and then we will finally update our player x's position. I mean player's x position. So player.x plus player.speed. Oh, I'm going to type out speed times dt. So this will make our player move. Now, else if our love.keyboard.isDown, the player presses our left arrow, then we'll have to do some opposites. So first of all, is moving will obviously be true since we are detecting some keyboard input, but facing left in this case will be true since the player is pressing the left arrow key. And after that, we will do player.x equals player.x minus player.speed times dt. Now if you don't know what is going on, we are basically decreasing the value of our x coordinate so that it does not only seem, it creates the effect of our player moving left, since its x coordinate value, which we measure from the left corner of our screen, it decreases, so it moves towards the left. So that is what is happening here, and it is exactly the opposite in our right arrow key. We have to increase the x coordinate so that our player's PNG moves right. So that is what is happening inside this. Now we have defined all of the logic for our player movement. Let me just close our love.update function. Now after this, we have to actually draw the player onto our screen. So in order to do that, we'll have to use our love.draw function. Now as for love.draw, we'll use if facing left. So since our default sprite sheet is facing right, we'll first of all create a condition for facing left. If our player is facing left, that is, it detects the left arrow key input, we'll use love.graphics.draw. Inside it, we'll have to reference our sprite sheet, and after that, we'll have to reference our quad, which will be quads, and inside quads, we'll show our current frame on the game window. And after that, we'll use player.x, this is our x position, and player.y, this will be our y position, and after that our rotation value will be 0. And since this image is pretty small, we want to make it visible, so I'll increase it by a factor of 2. So our x scale will be 2 and our y scale will be 2 as well. And in order to balance the flipping mechanism, I'll have to add the player's width, actually 2 times the player's width, since we are increasing by a scale of 2. So player.x, no, I mean player.width. I believe we have defined, oh, I meant frame width, sorry. Our player is essentially our sprite sheet's frame, so frame width. Now that is if our player is facing left. If our player is facing right, we'll do love.graphics.draw. Once again, sprite sheet. Oh, this should be -2 actually, since it is flipping left. This should be -2. It'll rotate our scale, so it'll be facing left. So sprite sheet, and then once again quads, current frame, in this case it will be player.x only and player.y only, and then 0 and then 2 and 2 for our scale. After that we'll end the love.draw function. So let's execute our code. So before testing out our code, I found out that I referenced frame width incorrectly. I forgot to write out capital. Now let's test our code and let's see if it is working properly. So you can see that our character is walking pretty fine, and it is facing left and right as well. Pretty smooth animation, you can see, and that is how it works. So great job, you just built your first frame by frame animation, not by using separate PNGs, but this time using sprite sheets. So if you found the video helpful, hope you drop a like and subscribe to our channel for more such videos. And until our next video, bye bye and happy coding. I'll be leaving the source code for this down in the description as well. You can go check it out, and you can go check out our new episodes and latest episodes as well. So bye bye and happy coding. Hey everyone, welcome back to the series that is the Love2D for Beginners series, and in today's episode we're learning something that will really level up your games, that is state management. Right now, if we just keep adding everything onto love.draw, love.load and love.update, our code will get messy and it'll be hard to control. So with states, we can neatly separate different parts of our game like the menu, the gameplay, and the game over screen. So let's dive right in and make our game smarter and more organized. Now you can think of game states like different modes your game can be in. First of all, there's the menu, which is shown at the starting of the game, that is the start screen. And next up there's the play screen, which will be running the main game. And next up the game over screen, which shows a loss screen or the score that you have accumulated. So we use a variable usually called the game state to track which mode we are in. And based on this value, we decide what to draw, what to update, and how to handle input. Now, after saying that, let's head on to our main.lua file. So let's open our previous folder and our main.lua, in which I have deleted all of the code, and we can start from scratch. So let's start by creating a simple project where the game has 3 states. One will be the menu screen. Next will be the gameplay, that is the action screen, and then the game over screen. So first of all, we'll create a love.load function in order to define the game state variable. So game state will first default to menu. So we will start at the menu, and after that we'll set a timer whose value will be 5, and we'll use this later for gameplay. Now this will be used in order to transition from our playing screen to our game over screen. We'll use the timer to simulate a game over. And after that, first of all, let's define and set our love.update function inside a dt, but for now we'll keep here nothing. Now first of all, let's draw the actual game state of our menu option. So game state, which will equal to menu. So function love.draw, if our game state equals to menu, then first of all let's set our font, so font size. So set font love.graphics.new font and 48. After that, let's set the color first. So love.graphics set color. Let's set our menu screen color to I think menu screen white is good, so 0 0 0. We don't have to do this explicitly, but I am doing this either way. So now what we will use is love.graphics.printf, and it'll go like love.graphics.printf. Now it'll take these arguments. First of all, this stands for printf, stands for formatted text. So our text that we want to print, after that the position values, so x and y, and then the limit of the text, that is how much space, the maximum limit the text should take, and after that the alignment of the text. So in our case we'll be using love.graphics.printf, and for that we will first print out press, and let's say this is the menu screen, then use \n to go to our new line and press enter to start. And after that, for our x position value we'll put a 0. For our y position we want to kind of display it at the middle, so we'll keep 200 from the top. And after that we will set a limit to the width of our game window, so love.graphics.getWidth, and then after that we'll have to display it at the center, so center. Now this is our alignment. So the second and third arguments, 0 and 200, set the position of the rectangle on the screen. It starts from the top left corner, so 0 means our left side, and 300 means 200 means 200 units from the top, so from our top 200 units down. And after that, the love.graphics.getWidth means that it tells Love2D to make the rectangle as wide as the entire game window, and in that entire game window's width, this alignment, there's align property, centers the text. So that is about it. Now after that, this was for our game state menu. Now let's say we have to define a state for when the game is being played. So else if game state equals play, then love.graphics.setColor. Let's say we'll set our color to green. So these are RGB values. So red is 0, green is 1, and blue is 0, and the alpha value will be 1. So first let's draw a circle. So love.graphics.circle, we will fill the circle and then draw it at 400 the x position and 300 y position, and after that its radius will be 30. So let's say this is our place holder for our gameplay. Now we have defined a state for play. Let's define a state for game over. So else if our game state is game over, then what we can do is we can print first let's set the color to red so that it signifies game over. So love.graphics.setColor will be 1, 0, and 0, and 1. And after that it will be love.graphics.printf, and inside it we'll print out game over, and then press R to restart. And after that we'll once again put in 300 and love.graphics.getWidth, and after that we'll center it. So this is our center. Now let's say that is it for our love.draw. Let's see what it outputs to. First of all, okay, the auto save is turned on. Let's run. Okay, it does not output to anything. Oh, my bad. I think all of this should be 1. Yep, so that should have been 1. My bad, it was all zeros. So this is our game start. You can see that this is menu screen. Press enter to start is being printed. Now when I press enter, nothing happens because we haven't defined the logic for that inside love.update. Now let's see what will happen if I turn this to play. And once again, let me run this. So you can see that a circle is shown on the screen, which signifies our play state. Now if I write here game over, then once again run this, you can see that game over, press R to restart is being printed out. Now I don't know why this is so small, but let me once again define our new font. There we go. Okay, let me close all of the game windows and let's move on towards defining our logic. So now let's make the enter key start the game from the menu and the R key restart it from game over. So inside love.update, no, not inside love.update, in order to use our keys, we'll have to define a function called love.keyPressed. And inside it will take the key parameter and inside our function. Now inside Love2D, enter key is called return. So now we'll type if game state equals menu, and okay, this should be double equals to, and our key is equal to return, then the game state should move on to play. So play, and after that, else if our, okay, let's say our game state is equal to game over and key equals to R, then in order to restart the game, let's say it has to move on to menu. Okay, let's delete this, and let's say it has to move on to menu, so we have to define game state equals to menu. Now that is it for switching between menu and play and game over and menu. But in order to define the logic for the game actually being over, we have to head on to our love.update. Now inside love.update, instead of nothing, we can do if the game state is play, then let's say we have to simulate game being over after 5 seconds. So we can use timer equals timer minus dt, which stands for delta time. And if the timer reaches 0, so let's say if timer is less than or equal to 0, then the game state will equal to game over, and the timer will equal to 5. So this is resetting our timer for the next round. Now that was it for our love.update function. So let's execute our game and see if it runs. Okay, for now I have defaulted this to game over. Now okay, let's see if I press R. Okay, if I press R, this will take us to the menu screen once again. If I press enter, it will take us to our play screen. Now we are taking the, see, after 5 seconds our after 5 seconds our game will go over to game over, since we have, when our timer reaches 0, we have turned our state into game over. So this is essentially what we were trying to achieve today. So game over, if I press R and then enter, it will start the game, and after a count of 5 seconds it will take us to game over. Now in order to actually visualize the time seconds, let's apply something in our love.draw. So instead of just printing out a circle, we can use love.graphics.printf once again, and then let's say we'll indicate our timer like this. So timer and then dot dot, and we'll use something called math.seal. Now what this will do is, instead of displaying point values, so suppose our timer reaches the time of 3.2 seconds. So instead of displaying 3.2, it'll display the upper round number. So it'll round up the 3.2, its upper bound, so it'll equal to 4. So 3.2 will also equal to 4, 3.1 will also equal to 4, but 3 will equal to 3, and 2.9 will also equal to 3. So I hope it is easy to visualize, but that is what we're doing here. So after that, once again we'll use our coordinate values, that is 0 and 300, and after that we'll use love.graphics.getWidth, and then we will center it. So that was about it. Now let's execute our game once again. Okay, let me first turn this to menu, since we want to load our menu screen at first. So okay, this is the menu screen. Now if you press enter, the game starts and the timer counts down to all the way to 0, and if it reaches 0, it says game over, and if I press R, it'll restart the whole game. Now that was the basic gist of this video. I know this was pretty simple and pretty short, but that is how game states work. Now for a challenge, you can try adding a score counter that resets every time you go back to the menu. The hint is to create a score variable inside love.load and increase it while playing, but reset it whenever the player goes back to the menu. Or you can even try adding a pause state, where you can set the game state to pause, and you can define your own conditions, and you can draw your own stuff on the screen when the game state is paused. And you can put here, instead of key equals to R, you can say when the game is playing and the key is equal to P, then it will pause the game. So there are many things that you can try with these game states, and that was the basic gist of this video. And that is a wrap for this episode. Now you know how to build menus, gameplay, and game over screens using simple Lua code and state variables. If you found the video helpful, hit that like button and subscribe to our channel for more such videos. And until the next episode, see you then, and happy coding. Bye bye. Hey everyone, welcome back to the final episode of this beginner-friendly Love2D series. Well, the final episode is going to be about exporting your Love2D game. So far we have tried out many things in Love2D, and we have also made a mini game called Pong. And today in this video, basically I'm going to teach you how you can export any game that you made. And for to use as an example, I'm going to use our Pong game. So today we're going to do something super exciting. We're going to package our game so that you can share it with the world. And whether you're sending it to friends or uploading it online, I'll show you how to export it properly, both as a .love file and as a standalone windows.exe, that is executable file. And just a quick shout out, if you are learning Lua, you can check out our app on the Play Store, Lua for Games to Learn and Code. It is packed with interactive courses, fun coding challenges, and a built-in Lua compiler and step-by-step guides to build games like Brick Breaker. It is perfect for beginners who want to learn and practice Lua all in one place. So you can go check it out on the Play Store from Codin, Lua for Games, Learn and Code. Now let's get on with the video. So first of all, what is a .love file? A .love file is basically a zipped version of your game folder, and the Love engine can run this file directly. So inside the .love file or inside your game folder, all of your code, images, and sounds, basically everything that your game requires to run, should be inside one folder with the main.lua file at the root. So let's explore all of that by creating a folder. So this is our Pong demo folder, in which I have our Pong game that runs properly. And this, we are going to be basically exporting this game and making a copy of it. So let's make a folder called export, right, first. And inside this, I'll copy all of these files and paste them right here. Now after that, the folder structure should look something like this. There should be your main.lua file. This run file isn't necessary at all, and all of the assets that you require should be inside this folder right here, the export folder. Now once you have all of your files ready, you can select them all, and I hope you have WinRAR or any zipping software ready. If you have WinRAR installed, you can go to add to archive, and inside this archive format you can select .zip, and this will compress it to a .zip file. So as you can see, we have compressed it to a .zip file, and you can go inside this. You can go to file, and okay, you can just cancel that. You can go to file and then save archive copy as, and then you can select a location. I'm going to select the desktop. You can name this as, let's say, game.love. So when you change it to game.love and save, and then you go to your desktop, you can see that a file with the Love2D icon is right here, and you can see that type is named as love game file. Now if you have Love2D installed on your device or your PC, you can just double click this and the game will start to run. So you can see that the game has started to run if I double click that, or you can just drag this onto the Love2D executable file and it will start to run. Now that is for when you have Love2D installed on your device. Now what would you do if your friend wants to try out your game but he or she doesn't have Love2D installed on their device? And for that, you have a standard executable file that helps the friend to try out your game. So in order to create a .exe file, you can just head over to love2d.org, and first of all install your zipped version of Love2D. So whichever type your device is based, 64-bit or 32-bit, mine is 64-bit, so I'll download this. You can see that I've downloaded that, and first of all you can create another folder. So let's say executable underscore export. So you can go inside this, and you can go inside your downloads folder first of all, and then you can go inside this zip file that you downloaded of Love2D, and you have to basically copy first of all the love.exe file and all of the .dll file that are present inside this zip. So you can copy them, and then you can head over to your export file, so executable export, and you can paste them here. Now after doing that, you can drag and drop your game.love file that you just created, which has your Love2D game. And in order to make a .exe version, you can first of all open up command prompt inside this folder and then type out this command. So copy /b love.exe plus game.love, or any name that you have given. In my case, I named it game, so I'm typing out game.love, and after that you can hit space and then whatever you want to name your executable. So let's say I want to name it Pong game.exe. So if I hit enter, and after that you can see that Pong game is present here. Now instead of a diamond shaped Love2D file, you can see type love game file. When I hover over this, it will say okay, it doesn't show right here, but so let me open properties, and you can see that type of file, it is an application, that it is an executable file. So whenever your friend downloads this folder, but keep in mind that you have to have all of the DLL files installed, and after that you can just delete the love.exe and the game.love, since we have already copied those into our Pong game.executable file. Now whenever your friend downloads this folder right here, and inside he or she opens the Pong game, he or she can play the Pong game that you just created. Not just Pong game, any game that you have created. And that is the basic gist of how you can export your game onto an executable file or a .love file. Now, some things that you have to keep in mind are that you have to keep all of the DLL files that you downloaded from your zip file, or else the game won't launch. So always copy all of the DLL files. And next, you have to keep in mind the version that your system is. So mine is 64, so I downloaded 64-bit. If your device is 32-bit, you can download 32-bit as well. And sometimes your Windows might give you a warning saying, unknown publisher, and that is normal since your .exe file isn't digitally signed, so it is safe to ignore. So that is it for this video. Now, some tips are you can also include a readme file, text file, to explain how your game works, or if you want to explain the game mechanism to your friends or any people that view your game. So that is it for this video. It was a short video and short and sweet ending for our Love2D for Beginners series. You have now built a complete game, added sounds, animations, even pictures, and all of the other stuff that I've taught, and you have now finally learned how to export and share it. So I hope this series has proved helpful to you guys, and you guys loved this series and hopefully learned a lot of stuff along the way. So if you like this video and the entirety of the Love2D for Beginners series, make sure you drop a like and subscribe to our channel for more such videos and series. So until our next video, bye bye and happy coding.